Okay, so for Windows, you're going to be doing basically all of your work through Ubuntu Linux, which is built into Windows. And if you haven't used it before, you need to set it up. So if you click on the install steps link, it'll bring up the installation guide, but the short version is this. Open up PowerShell as administrator. If you're a Windows user that haven't used PowerShell, you're missing out. It's the most amazingly awesome thing. But to use it, you basically bring up your start menu, start typing PowerShell, and then you can right click and say run as administrator. That'll ask you if you want to do that. You say yes, and then you can just copy and paste this command. So to paste that command, you can type Control-V or right-click. And what that will do is it will install the Linux, it'll enable the Linux subsystem for your computer. If it's already enabled, it'll say restart needed false. So it is for me. If yours says restart needed true, you need to restart your computer now. So reboot if necessary. The other thing you need to do to use anything that Microsoft considers a little dangerous and scary is say that you're a developer by switching on developer mode. So if you again type start and start typing in developer, you can see here use developer features, and you can go ahead and turn on developer mode, and that's going to basically turn off a bunch of safety settings on your computer, things like using Linux. Okay, so once you've done those two things, you can open up a command prompt. So command prompt and type bash. So bash is something that you'll all be using. Bash is the name of the shell, the name of the thing that you'll be typing all of your commands into throughout this course. And so if we try to run bash, the first time you try to run it, it'll say, do you want to install Ubuntu Linux? Say yes. It'll take 5 or 10 minutes. If you're on a slow connection, it could take quite a bit longer because it has to download it. If you have the most recent update to Windows, which just came out like yesterday, you can actually just go to the store and search for Ubuntu, and you can actually install it from the store. So great. So you can see at that point I have a bash prompt flashing here. And then exit will exit. So once you've got that going, 5 or 10 minutes, you can open up another tab or another shell or whatever to keep working while that's happening in the background. If you're a Mac user, yes, Jeanette, can I give you this?
Yeah. So I don't use Windows. Oh, yeah. So will the PowerShell command work on Windows 8.1?
Yeah, PowerShell should work on Windows 8.1. If it doesn't, just Google for Windows subsystem for Linux. That's what this thing is called, and Windows 8.1, and you'll find the Windows 8.1 installation guide from Microsoft, so you can follow that. And when you speak into that, speak as loudly as you can as well, because the microphone needs to pick up this. Now, yeah, so if you're a Mac user, you need to be using bash as well. And so this is slightly confusing, but there are two pieces when you're using bash. One is the actual bash shell itself. That's the thing that puts up the prompts and that you type into. But then there's the whole window that bash appears in. That's called a terminal, right? So there's two pieces, the terminal and bash. On a Mac, you have a terminal already installed. So if you hit Apple space to bring up Spotlight and type terminal and press enter, bash will appear, okay? People that use the terminal a lot, which will be you, generally want to use a better one. So you may want to try downloading iTerm2, which is a freely available, greatly improved terminal for Mac. So if you've got a Mac and you haven't tried iTerm2 before, try try grabbing it now and see if that's useful. The other thing you'll need to install for Mac is Homebrew. You'll see that when we install stuff into Linux, and you'll all be using Linux through AWS as well, we use something called apt to install stuff. The equivalent in Mac OS is called Homebrew, and specifically the command is called brew. So if you go to this link, it'll show you something to paste into a terminal prompt, which will install Homebrew. And after that, you can just type brew install and the thing to install. So generally speaking, if I forget to mention this sometimes, I apologize, but generally speaking, when you see me say, I'm going to use apt install blah to install a piece of software, Mac users generally will go brew install blah. Okay. Having said that, you won't be actually typing stuff into a Mac very often. Most of the course is going to be done typing stuff into a server somewhere else, an Amazon server somewhere else, and that will be running Linux. So, is there a question? Okay. Great. Yanette, do we have any questions on the discussion? Somebody wants to know if we're going to have coffee breaks. Yes, we are. And I'm very grateful to those people who, basically everybody who's not in the US is joining us at times varying from 11 p.m. till 4 a.m. And yeah.
There was an international question that I don't know how to answer. That is there any way of getting an AWS account without a credit card?
Yeah, I actually saw that and I answered it on the international thread. We'll get there, but what I said there was please send me a private message and I'll see what I can do. We have some other options that we'll be talking about today. Yeah, okay, so Yanette, they're having some trouble hearing you. So just speak up as much as you can, and I'll turn this up. Try speaking up again.
Hello?
Loudly.
Hello?
Great. So I'll say something.
Hi, everyone.
Okay. Let us know if you're still having trouble hearing Yanette. Thank you for letting us know, Eric. Oh yes, okay, that's true. Windows 8.1 doesn't support Linux subsystem. That's true. So if you're not using Windows 10, instead you need to use something called Cygwin. So if you type Cygwin, C-Y-G-Win, if you're using Windows less than 10, you can click on Setup here, download it and run Setup. And you'll find that you can install, that gives you a bash shell as well. And so you can do everything that we're talking about in the course through Cygwin instead. It's not as compatible with Linux as the Windows 10 one, which is really a full version of Ubuntu Linux, but it's pretty close and should be good enough for the course. So let's add that here for Windows 8.1 users use Cygwin. Great. Okay. So the next thing we're going to do is set up an AWS account if you don't have one. So AWS stands for Amazon Web Services. Who here has heard of AWS before? Yeah, nearly all of you. So it's something that lets you fire up a server, which can range from tiny and free up to servers that cost $15 an hour and have many GPUs and many CPUs and many hundreds of gigabytes of RAM. one of the nice things about this is that some of those servers have GPUs in them. Your laptop probably doesn't have a deep learning compatible GPU in it. So this is something, and most people I know, including most of the most serious researchers and practitioners, use AWS for most of their work, right? So that'll make you, it's a kind of, getting familiar with AWS is something you'll want to do regardless. It's one of 3 options I'll be showing you for getting a GPU server in the cloud today. Why am I showing you multiple options? Well, AWS, Amazon are going to be giving us some treats. So by having an AWS account, you get that treat. Paperspace also has a special code to give us some free hours. And Cressel, the other one we're using, also has some free hours. So one thing is, by literally the free hours from the group of them, you'll keep you going for quite a while without having to pay. They each have different strengths and weaknesses, as you'll see. And you might find there are particular ones you like or don't like. Also, some people will have trouble accessing some. So for example, some international folks might have trouble with getting your credit card through AWS. But you might be able to get set up in Paperspace. So by having options, we have fallback plans for everybody. Can have that.
For the AWS account, if you have an account already, does the credit still apply?
Yes, absolutely. So Mindy will have sent you an email asking you to update this spreadsheet where you need to put in your AWS ID. And the AWS folks we're dealing with have access to this spreadsheet, so that's how they know who to give treats to. Okay, so I noticed that there's quite a few people that don't have AWS IDs yet here, so thank you so much.
So we will have to use either of the 3, like AWS, Paperspace, or Cressel, right?
You'll need to use an NVIDIA-based GPU, and we'll talk about this shortly. So if you don't have a server or something at home you've specifically configured for that purpose, you'll need to use one of these unless you somehow have access to something else.
So if I'm using GPUs in AWS, I don't need to use Paperspace. Or...
Right, you don't need to use all of these. But as I say, there are some free hours attached to each one, so if you want some, and I'll also show you that Paperspace has some neat tricks that AWS doesn't have. But once we've looked at all of them, we're going to have a talk about the differences. Yeah. And so for today, you may as well go ahead and sign up for these things unless you have some strong reason not to, just so that you can experiment. One of the nice things about Paperspace is they have much, much, much better GPUs than AWS currently has. So your training will be running much, much slower if you use AWS right now. Okay, so to create your AWS account, follow the instructions in the link. And one reason to do it now is that it needs to call or text you with an authentication code. That's then going to get manually checked, and it can take 10 minutes for it to be approved. In some cases, if they're having problems with your credit card, it can take 24 hours to be approved. But hopefully, if you sign up right now, you should have it up and running in the next few minutes. Okay, so while some of you are doing that, let's talk a little bit about GPUs. So GPU is a graphics processing unit. They were created to play computer games. Basically, a lot of the work necessary to put the right pixels on your screen for a computer game involved doing stuff with linear algebra. So basically figuring out how to rotate something in 3 dimensions and then project it to 2 dimensions so it can appear on your screen involves a whole bunch of matrix multiplications. It turns out that regular CPUs don't do that as quickly as they could because they've got too much smarts in them. They're really designed to be able to handle a much wider array of things. And it turns out you can create processors that really are very specialized towards doing like matrix multiplications and stuff like that, which can do them much, much faster. Because computer games are, I believe, the world's largest entertainment industry by quite some amount, many, many, many billions of dollars have been put into making GPUs faster. So for the last 10 years or so, there's been a constant trend of the best GPUs being about 10 times faster than the best CPUs. It turns out that deep learning also basically involves doing lots of matrix multiplications. So it turns out that GPUs are also really great for deep learning. You don't need to use a GPU, and indeed you can play around with stuff on your own laptop, even without one. But it runs, you know, somewhere between 10 and 100 times slower on, you know, without using a GPU. When we talk about a GPU, we're talking about a particular kind of GPU. We're talking about a GPU manufactured by a company called NVIDIA. And that's because NVIDIA uses something called CUDA. CUDA is a programming language for programming GPUs. Basically, it's designed to program things other than doing computer games. There are other languages for this kind of general purpose graphics programming nowadays other than CUDA, but because CUDA was the first and they're still, you know, really ahead of everybody else, pretty much all the deep learning libraries either require CUDA or are much better on CUDA or have much, you know, at least have a lot more resources for CUDA. So everybody pretty much in deep learning uses NVIDIA based cards with CUDA. And so all of the cloud-based systems we'll be talking about all use NVIDIA cards with CUDA. Unfortunately, this is somewhere where if you want to do this stuff at home, you won't want to be wanting to use a Mac, because Macs don't use these kinds of graphics cards, and also Macs generally don't have good quality GPUs anyway. So if down the track you get into this enough that you feel like you'd like to run your own deep learning box, you'll find there's lots of resources on the forums, and they'll all be about using Linux, generally Ubuntu, and indeed all of the servers will be accessing generally use Ubuntu Linux. AWS is somewhere that we can go and, as I say, get access charged by the minute to a server of whatever size we want. They do a hell of a lot more. So when you get your login and you go to your AWS console and click services, you'll see there is a lot of stuff. The only thing we'll be using is EC2. EC is Elastic Compute. So this is the thing that lets you get compute, get servers. So you can click EC2. And actually you can pin services to the top. So you can see I've actually got EC2 pinned up here so that you can get access to it more quickly. So yeah, generally you won't have to worry about anything else much in EC2. The only other two things you may need to worry about is IAM, which is the authentication management. That's where you can kind of set up users and authentication. And VPC, which is where you can set up your networking stuff. So those are the only three things you might need to touch. Okay. So we're going to come back to AWS, but for now we just wanted to make sure you could get logged in. And don't forget to come back to the spreadsheet and put your AWS ID in here. All right. Right now, we're in a weird situation where the big cloud providers, Amazon and Microsoft, Amazon with AWS and Microsoft with Azure, have very, very, very old GPUs, are the only things you can access. NVIDIA names their series of GPUs after famous scientists. and generally the first letter of that is what they're then known by. So there's a series called Kepler, which is K, then Maxwell, which is M, and then Pascal, which is P. So we're currently actually well past Pascal, yet Amazon and Microsoft still have Kepler-based cards, so they're kind of at least 3 generations obsolete. There is a new company called Paperspace, which has done a great job of having current GPUs. And not only are their GPUs actually current, and therefore faster, like 5, 6, 7 times faster, they're cheaper for the same amount of time, which is kind of weird that that's possible, but there you go. So I would highly recommend giving them a go. So let's work through this together. So go to paperspace.com, go to sign up. Go ahead and sign up, and it'll be basically instant. And then sign in. And so while you're doing that, there's a question from Sanyam Bhutani asking, do you suggest building a deep learning rig at home or use AWS and friends? I would say for now, go ahead and use the online stuff because of our credits. You know, you can get started for free. Make sure that you really want to do this. Learn a bit about what your priorities are and what you want, and yeah, at some point you will probably want to put something together at home, assuming that you could decide to invest in this longer term, because a box at home ends up being a lot cheaper. You can buy one of the best graphics cards or GPUs available for about $700. And the Paperspace stuff we'll use costs 65 cents an hour, assuming that from time to time you accidentally leave it running overnight, then you kind of end up,
Yes.
You did see that yesterday, yeah. You can certainly use up $700 in a small number of months. So we'll talk about that more during the course. For part 2 of the course, there's like 7 lessons in part 1, and then if you want to keep going, there's 7 lessons in part 2. By the time people get to part 2, we tell everybody you should get your own box, because by that point, relying on cloud servers is just not very economical. I don't quite understand this question from Omar Anin. Are there statistics for ranges, participants, previous courses? I assume that's the amount of money. Yeah. So we say 10 hours a week for 7 weeks. Do you want to? Yeah, I know that's about money, so it's going to turn that into money.
Spending about like how much?
So I mean, that the thing we were using was 90 cents an hour. So that's going to be about $60 or $70. But again, assuming that sometimes you forget to turn it off, it could be more like $100 to $150. But hopefully we'll have enough treats this time around that we can get through the course without paying anything, or at least not too much. I know also, like, if there are folks, particularly in the International Fellowship or Diversity Fellows, who are having trouble completing the course because of financial issues, if you let us know, we can probably get you a sponsor of some kind. GTX 1080s are fantastic, to the person who asked that question. Okay, so to get credit from AWS, Mohammed, you need to look at the emails. I assume you're an international fellow. You need to look at the email that I sent you, where I've got a link to where you put your AWS ID. And I don't know how many AWS credits, if any, we'll have. I'm just saying there'll be treats. So wait and see. Okay, so hopefully anybody got any issues with getting signed up to Paperspace? Awesome. So now you can go ahead and create a machine. Now, nearly every cloud provider will let you choose where to create a machine. Sometimes they'll say choose your data center. In this case, Paperspace makes it very easy by actually showing you where they are. So you should decide which one of these dots is closest to where you live, and that's going to make it the fastest for you. So for everybody who's here, we're obviously going to pick the one on the West Coast in California. And so when you create this machine, it's going to create it in the data center that is where you've asked for it. And the closer it is to you, the faster it will be to access. And then it says, what OS do you want? And I think by default, it gives you Windows. If you go to public templates, you'll see actually there's one here that says fast.ai. So that makes it nice and easy to get started. So different cloud providers call things, Amazon calls them AMIs, Amazon Machine Instances. Microsoft Azure, I think, calls them virtual machines. But basically every cloud provider will have some way of, like, when you fire up your machine, it will be pre-installed with various stuff, okay? So this is going to have various stuff for doing the FastAI course. So then you choose hourly, and then as with all cloud providers, you can pick how much to spend. This M, so the GPU here is a Quattro M4000. So the M means it's a Maxwell generation, so that's the previous generation of cards. This one over here is a P5000, so this is a Pascal, which is more or less the current generation of cards. So if you can afford the 65 cents an hour, I would suggest this one. When you try to fire it up, it'll tell you that you haven't got permission and that you need to request permission and say, what is this for? So just type in fast.ai, and the folks at Paperspace know to look out for that, and hopefully you'll get that permission granted, you know, well before this class is finished. Fast.ai.
The question was where?
When you click this button and say please launch it, it'll say you're not allowed to, and it'll bring up a text box. Yes.
But by the way, just I just tried one of our notebooks on the older one, the 40 cents one. It runs as fast as our, you know, it's just as well, yeah.
Yeah, while you're waiting for that to be approved, or if you'd rather not spend 65 cents an hour, go ahead and use the 40 cent an hour one. It's still terrific. It's still much better than any of the Amazon ones. The difference is the P5000 will run, you know, twice as quickly, maybe a little faster, and it's got a lot more memory. Now, when I say memory, normally you'd think about the RAM in your computer, but the graphics card has its own RAM. And the more RAM in the graphics card, the better. It means that you can process more images at a time. You can handle bigger networks. So, you know, that's why this is nice. Now, the other good news is that they're going to give us $15 worth of credit. So if you type this here, FastAI 15, at the bottom here, all the way to the bottom, it says promo code. And so when you type in or paste in the FastAI 15, it'll give you $15 of credit. So if you use the 40 cents one, then that's actually going to keep you going for 30 hours plus of computing time. So that's quite a bit. Okay, so I'm going to pick the 65 cent one. As well as paying for each minute that you're on the machine, you also pay for each month that you're storing stuff. And you have to say up front how much you want to store. Again, if you can afford an extra $1 a month, I would highly recommend going with 100 gig, because that's going to let you store lots of deep learning data sets. And deep learning data sets can be pretty big. If you can afford an extra $1 a month ahead of that, $7 a month, you will let you store like everything. You know, you won't have to worry about storage ever. So I might go ahead and go 250 gig, 65 cents an hour, you can have it save a backup of your entire computer for you. If you do that, you're going to be paying for basically twice that amount of space, right? I don't particularly need that myself, so I turn that off. For an extra $3 a month, you can get something called a public IP. A public IP will let you, and we'll learn a lot about this shortly, but it'll basically let you use this Paperspace machine in exactly the same way as an AWS machine. You'll be able to like log into it through a terminal and do anything you want to. I'm going to leave that off for now so I can, actually I'll do both. I'll turn it on, but I'll show you how to use it without the public IP. So you'll need to put in some payment information, create your Paperspace. And so this basic process is what pretty much all cloud providers look like. Pick a location, pick a type of machine, pick an amount of storage. Paperspace's version looks a little easier, I think a little more user-friendly than most, but the basic idea is the same. So after that happens, you'll see the machine appears, okay, along with any other machines you've created. You can add more. And it says provisioning. So it's going to take a few minutes for it basically to set up that machine for you. Probably less than 5 minutes, I think, isn't it? Yeah. Can I grab that box?
If we go with Paperspace, do we still need to have Amazon account?
So we'll talk about the differences between these and which ones to pick. But the Amazon account, you're going to get hopefully some really cool free toys, which I can't talk about yet. So
okay.
You don't have to do anything.
So we can have both as well?
I would suggest getting all of these set up today so that they're all there.
Okay, thank you.
Unless you use more than $15 worth, it's not going to cost you anything. You know, you're putting your credit card in there, so just in case if you do use more, it's not going to cost them money.
So if we choose the 40 cents today, will we be able to switch to the 65?
Yeah, you can always add another one. In theory, you can, actually this is finished provisioning. So if you click the little setup icon, there's an upgrade button. I'll turn off your machine before upgrading. In practice, I found I was able to upgrade storage, but I couldn't upgrade the GPU. So you'll probably need to, assuming that you find the same thing, you'll probably need to click the plus and create a new one and delete your old one.
Okay, so you mentioned that there's another option in place of the Paperspace public IP. Would you recommend the Paperspace public IP or the option that you?
Well, the option is on or off, right? If you turn it on, you get you get both options. You get the one I'm about to show you, or the one that your net's going to show you. So if you've got the $3 a month, I would definitely turn it on. It is more convenient, and also you'll be using something called SSH, which is something which kind of everyone uses. So if you're going to get into the data science world, or even just the cloud computing world more generally, you're definitely going to want to learn about that. Okay, let me make sure everybody's name is added. Okay, so I'm just adding additional people to the forum now. So if you only recently added yourself, you should be okay now. All right, so I'm going to go ahead and click on launch. And this is kind of crazy amazing what this can do. But you'll see what it's done is to create a whole window inside my browser, which is looking a little small at the moment. Full screen. If you click on this little circle, you get a special Paperspace menu, full screen. Yeah, so you get this like whole computer in a computer. The reason mine's looking tiny and terrible is because I'm using very low resolution screen for the purpose of projecting. Hopefully on your computer, when you launch it, it'll look a lot better. And so this is basically an entire Ubuntu Linux desktop. And so, yeah, as soon as you click full screen, you've got a full screen Linux desktop. Most of the time, we aren't going to use anything other than the terminal. So what we're going to do is we're going to set up the console so that we can basically use the console. So if you click on this bottom icon here, this brings up terminal in Ubuntu, and you can maximize it. So one way, maybe this is actually kind of in some ways the easiest way to do this. So this basically gives you a full screen Linux console attached to a very powerful GPU. And we're up and running. And so this is actually pretty revolutionary until very recently, the idea of being able to have a deep learning capable high performance GPU server running in your browser was unheard of. So this is one way to do this. The other thing you can do is if you look in your email, you will find that they've sent you an email with your password. What you can do once you've got that is you can type PASSWD to change your password. Okay? And so you can change it to whatever you like. And then once you've done that, you can actually go into a version that is just a console. So you can basically click on that little menu and you can go console, and it'll switch over. Oh, sorry, that was not the right button. I didn't mean to say console, I meant to say terminal view, sorry, terminal view. And if you full screen that, then as you can see, it basically uses the whole screen just for the terminal. So there's a couple of ways to get Paperspace up and running. And we'll talk again more about how to use it shortly. For today, a lot of you will probably find, where's that? Oh, thank you. A lot of you will probably find Paperspace is a good option because you can have it running straight away. You don't have to worry about SSH, etc., and you'll have a pretty fast GPU. Yes?
How do I turn on and off Paperspace? I mean, I see there is a...
Yes, good question. So if you leave this running, it's going to be costing you 40 cents or 65 cents an hour. And by the way, to switch back to that full desktop view, I can click switch to desktop. All right, and I can move it out of full screen or into full screen. So yeah, so what you can do is you can go back to the kind of main dashboard, which they call the console, by clicking on console here. There's a couple of ways to do it actually. And then if you click on the little settings button, you can click shutdown. So that's one way to do it. Perhaps more convenient is from the computer itself, you can type shutdown -H now. Now, if I try to do that, I get a message, need to be root. We'll be talking about this more shortly, but basically in Linux, most things that kind of change the computer's state in any way, you need to provide authentication for. And so to do that, you simply prefix a command with the word sudo. That stands for super user do. So do something as the super user, like the admin. And if you run that, it'll ask you for your password, and then it'll go ahead and shut it down. Okay. In general, if you want to know anything like how do I shut down a Linux box, just Google for like shutdown Linux or reboot Linux, because this is a full Linux computer.
So if I start using the 40 cents an hour box and then I decided to move to 65 cents an hour, do I have to like move the data myself?
Yeah, I think you do. Yeah. Although we'll be learning from Yannet about how to use things like Git today, which makes that very easy. The other nice thing about Paperspace is because they have this special FastAI image that we've used, you'll find all the software that we're using in the course is already there. So that's another good reason we'll be using that mainly today. Yeah, so I might go ahead and, here's another way to shut down. Click the little circle and shut down machine. Paperspace also has a pretty good FAQ. So if you Google for like Paperspace shutdown, it'll generally get you to a FAQ entry telling you what to do. Okay. Yes, can we have the green box, please?
It looks like that people having trouble with getting a Paperspace machine, but I guess we don't, maybe too many of us are accessing the same time.
Could you email Dylan?
Yeah.
Thank you. Can we use Google Cloud Platform? Only if you know what you're doing. We're not going to be providing a guide for that. But if you're interested in Google Cloud Platform, I mean, it'll certainly work. And in previous courses, enthusiasts have often created information about how to use other platforms, and then they post it to the forum. So if you decide to give it a go, it's a good learning experience, and then you can post it to the forum and other people can help you and so forth. So feel free to, but only if you have the time and enthusiasm to work through that. Yes, it only costs money if the machine's running on Paperspace or AWS, so just make sure you remember to shut it down. Your billing zip is just your postcode. Yeah, so the request you made to get access to the P5000 is going to be looked at by a human. So I asked the CEO yesterday if they could have some people looking out for it, but they're a small startup and they're busy, so it's whenever somebody gets around to looking at it. You'll get an email, I believe. Oh, there you go. Somebody's already provided a script for using Google Cloud, so that didn't take long, although that may be the old version, I'm not sure. I don't know if the webcam works with it. It'd be interesting to try out. Inaccessible. Okay, yeah, so Yannet's going to ask about that. Now, to copy and paste between Paperspace and your machine, you need to click the little circle and click on Sync Clipboard. It's a handy feature, but it doesn't work automatically. All right. So the final option to look at, and again, it's worth using, I mean, if nothing else, because you get, I think, like $15 worth of free hours, is Crestle. Crestle's actually built by a FastAI student from last year. It sits on top of AWS, so it has all the same caveats I mentioned about performance. It's still going to be dozens of times faster than your laptop, but it'll be slower than Paperspace. The benefit of Crestle is that you'll get instant access to it as soon as you sign up, and it'll give you instant access to like a real AWS instance with SSH and everything, which Sheila's going to talk about. So I do suggest today you try it, try signing up for Crestle now. And the other nice thing about Crestle is that all the FastAI data sets are all preloaded. So a lot of the stuff we will show you early on will use Crestle because the data sets are all there ready to go. You don't have to download them and stuff. So I do suggest checking that out as well, particularly those of you that were having trouble getting provisioned for Paperspace or getting your credit card working or whatever. And the guy that set up Crestle has been super great at answering our questions and requests and stuff. So if you have any problems with it, let us know. We should be able to sort them out. Okay, so while you finish getting those things set up and playing around with them, let's talk about the pros and cons. Actually, let's move that down slightly to after we set up our own laptops. So the last thing we're going to do is we're going to set up a basic scientific Python environment on our laptops right now. You won't be able to do much, if any, deep learning on your laptop. I mean, it's possible, but it's kind of frustratingly slow and not everything will work straight away because you don't have an NVIDIA GPU. But the stuff that we're going to be learning through the rest of the day, like using Git and Bash and NumPy and Pandas, all that stuff you can practice on your laptop, and it's just much more convenient. So I think it's nice to have a working scientific Python environment on your laptop. It also turns out to be super easy because there's a version of Python called Anaconda, which really just about every data scientist I know has now switched to, which has all the key things you need pre-installed. And it also makes installing additional stuff really easy because people pre-compile stuff and upload like the compiled versions to Anaconda for you to download. So there's this really strong data science community around it. So for those of you that already use Python for something else, I would very strongly suggest not using your like development Python or system Python or whatever, but installing Anaconda for this class. It'll install into your own home directory. It won't overwrite anything else, so you can easily, like, it won't cause any problems with other stuff that you're doing. You can switch back and forth. So that would be my suggestion. All right, so it's been an hour and a half nearly, so it's probably a good time for a break. So should we take a 15-minute break now? And yeah, feel free to keep fiddling around with what you're doing or go and have a walk around or whatever, and I'll see you back here at 11:40. Okay, so somebody who's obviously been using Python a bit has asked about the difference between Anaconda and virtual env. Anaconda is a fairly significant superset of virtual env, so it's not, if you're using virtual env please try Anaconda. For one thing, you can switch between Python versions with Anaconda. So if you're using Python 2 for something, you can easily switch to 3 for the purpose of this class and back. Anaconda has a lot of scientific Python pre-installed. If you're a strong Python expert, you can probably get away with just using virtualenv. But as I say, like, the vast majority of data scientists are using Anaconda now, and so like I feel like part of this, and I know like maybe about half the people in this course are very experienced software developers. Although we're using tools that you're familiar with, we're using them in different ways, and the ways that you've learned to be a good software developer won't necessarily translate directly to being a good data scientist. So, you know, I would encourage you to try the things that we're using for a while, and if you feel like it's not a great fit with your work, that's fine, but, you know, give it a go, because they're, you know, it's a different but overlapping piece of, you know, type of work with different but overlapping tools and processes. Okay, so if you've got Python 2.7 installed from FastAI Part 1, just Google for Conda upgrade Python, and you'll get, it's like 3 lines of, you know, basically create a new Conda environment, it's called. We'll look at that shortly. So I won't show you how to do it because it's very Googleable and straightforward, but let us know if you try and have problems. There you go, somebody's already provided the line of code you need. Great, these are all good answers, so thank you for everybody helping the other students. That's great, sounds like people are getting their paper space approvals, so good. Oh, okay, I didn't know this. So apparently deactivating a machine that you just spent $5 on storage for, they charge you further $5 for the month of storage anyway. I didn't know that, so that's probably good to know. So don't create and delete lots of machines. I guess that $5 a month gets charged up front. All right. So we're going to talk about how to use the terminal on your own computer. And so it's interesting, in last year's course, a lot of people were already, you know, because everybody's coded before, were already pretty familiar with using the terminal. But a lot of international fellows in particular had spent, you know, really all of their time in more graphical environments like Visual Studio or Eclipse or whatever. And so this kind of idea of using the terminal can seem a little intimidating because you know, when you open a terminal, which in Windows you can do just by typing bash or Ubuntu, you know, it doesn't look like a very friendly thing. This is this flashing thing. So, you know, is this a step back to be using like this old-fashioned looking console, or what? And the answer is no, it's definitely not a step back. Actually, increasingly, even developers who previously have used kind of GUI-based environments are using the console more and more, the terminal more and more, because you can use language, you know, you can combine commands in all kinds of rich ways to do things in a single line on the terminal that might have taken, you know, lots and lots and lots of button clicks in a GUI. And so more experienced developers often move towards using the terminal more and more. Which is not to say that things like Eclipse and IntelliJ and Visual Studio aren't great. They really are terrific, and people who only use a terminal are really missing out if you're not familiar with IDEs. But for data science in particular, the terminal is something we use a lot. There aren't really great Visual Studio-like tools for data science. There's lots of people who claim to have cool GUI-based tools for data science, but all the ones I've seen are kind of crappy. So, you'll get a lot of value by learning to use Bash. It's something that you'll use for the rest of your life. And for example, in data science, there's a whole range of tools you can use at the terminal that let you sort things, grab the top of things, grab the bottom of things, grab a subset based on a search of things. Like, you can really do a lot of manipulation in the terminal. You can copy things, onto AWS and back again. You can put things in version control and Git. You can do all kinds of stuff. And the cool thing is you can create these kind of pipelines of commands where, first of all you sort, and then you grab the first few lines, and then you search for something else, and then you print out the sum of this. Like, you can really put it together. So it's well worth investing in. So that's why we use a terminal. And just in the end, the fact is a large amount of the stuff that you need to do with deep learning is only possible through the terminal. So apart from anything else, you kind of have to. But I would say it's like not something I would say you have to do, so drag yourself to it kicking and screaming. It's more like you've got to do it, and once you get good at it, if you're not already, you'll discover it's a wonderful, rich thing to make a lot of your work much, much easier. I think another important thing is replication. In data science, as with many things, being able to repeat the steps that were taken to do something is really important. So apart from anything else, everything you type into Bash, later on you can just type history. So if I go ls cd ... history, you can see a list of all my commands. And so you can easily turn that into a script. Any list of Bash commands, if put into a text file, becomes a Bash script for free. So you can rerun them later, or at least show your colleagues what you did. So that's another good reason. So, okay, so with Windows, hopefully everybody's got Ubuntu installed. So as I said, if you just fire up your start menu and type Ubuntu, you can get that open. You can maximize it to get a bit more space. You can even press Alt-Enter to make it take up your whole screen, full screen, or Alt-Enter again to put it back. What I tend to do is I often, most operating systems give you multiple desktops, is I tend to put my console on a different desktop, and I tend to full screen it. So if you don't know, in Windows, you can press Windows Control Left to switch back and forth between your desktops. So I tend to have a terminal running in one and my more GUI stuff and browsers in another. That's something I find helpful. In Mac, you can fire up Spotlight with Apple Space and type terminal, or if you followed my suggestions and installed iTerm2, you can type iTerm2. And on Linux, if you're using Linux, I'm sure you already know. Many Linux distributions have a keyboard shortcut of Control-Alt-T to bring up a terminal, by the way, which a surprisingly number of people don't know. Once your terminal's open, Mac, Linux, and Windows users are all going to have the same thing, which is Bash. Right? So the actual thing that's printing out these lines and asking for input is called Bash. And Bash is a shell. So a shell is basically anything that lets us type in commands and return back responses. And shells generally let us create and run scripts or create pipelines and so forth. So I am currently in Bash. It shows me my username. It shows me the name of my computer. And it shows me my current path. So in all shells, there's always a concept of where are you now? So if you want to list the current directory, you would type ls. And so what is it lsing? It's lsing what is in home. All of the operating systems have the concept of a home directory. If you type cd for change directory and hit enter, you end up home. And home is, the shortcut for home is tilde. Okay, it's not really called tilde. If you print working directory, you'll see it's actually called, in my case, /home/jhoward, which is the normal approach in all types of Unix. So that's our shell. That's bash. So when people say use the console or use the terminal or use the shell or use bash, they mean slightly different things, but in practice they all mean do this. Okay. Yanet's going to be showing you more about how to use this effectively later on. We can only touch on it very briefly today. The difference between being extremely adept at your tools and vaguely knowing the basics of your tools is huge in software development in general, and certainly in data science. I don't know any of the best data scientists who, when I sit with them and watch them, aren't like, it's like just an extension of their brain. They're just like bringing up stuff from their history and putting it in and moving things around just because they know all the keyboard shortcuts. So if you're somebody who's done a lot of stuff with the GUI, you know, it's particularly worth learning the keyboard shortcuts and the aliases. And so, you know, Google for bash tips or bash tutorial. It'll be something that'll pay you back for the rest of your life, learning just using bash well. I think the one thing I'm going to show you right now is the up arrow button. Up arrow brings back your previous command. Each time you press it, it goes back a little bit further. And so you'll see it's basically going through my history. Right? And so once I find something that I want to change, I can go back and then I can just use left and right to change it and then type in that command. Okay. So we're going to use this to install Anaconda Python. Okay. So Anaconda Python is just regular Python, which comes with all the stuff you need for scientific and numeric programming, just about, and comes with a package manager. So a package manager is anything on your computer which helps you install, update, and delete software. It comes with a package manager for Python libraries. If you've used Python before, you'll be familiar with pip, which is what we've normally used. Conda can install a lot more stuff than pip can. So for example, you'll see when we get to looking at PyTorch in the course that the PyTorch installation command automatically installs the whole CUDA software development kit automatically. It also installs all the C++ standard libraries automatically. Like you have this whole Anaconda environment of everything that's necessary to run those modules. So generally speaking, installing something with Conda, which is the name of the Anaconda package manager, will not involve like first install all of these prerequisites with apt or brew or whatever. It'll be just like Conda install the thing and it'll install the prerequisites even if they're not Python things. So that's some of the benefits of it. You can have multiple versions of Python installed with Conda, and you can activate different Python versions. So it has all of the benefits of virtual env if you've used that, plus a whole lot more. We're going to be using Python 3.6. There was many years where pretty much everybody, me included, was stuck on Python 2. Mainly because most of the libraries didn't work on the newer Python 3. Nowadays, the opposite is true. Rapidly, more and more software is dropping support for Python 2. So if you're a Python programmer who is stuck with Python 2 because that's what we've all used for a long time, now's a good time to start moving away from that. A lot of the software we're going to need will not run properly on Python 2 or does not have any long-term support plans on Python 2. Also, we're going to be using stuff involving like concurrent and parallel programming, which does not have good Python 2 support. So please use Python 3. All of the stuff that we're going to be using does not run at all. Our library does not run on Python 2 at all. And so since it's so easy to switch back and forth, can you pass that back, Yanet? just over there. Since you're going to need Python 3, you know, if you need Python 2 for other things, at least learn how to switch back and forth with conda activate. Sorry, the top of this microphone has a tendency to fall off.
Hi, so do you have to use like 3.6, like if I have 3.5?
3.5 won't work with this course. Yeah. But you can switch back and forth between 3.5 and 3.6 if you just Google for conda upgrade Python, it'll show you how to activate one, activate the other. Python 3.6 has some convenient little features that we use a lot inside the library. So Python 3.7, on the other hand, is a pretty minor upgrade, so we're not really requiring anything there yet. All right, so let's get started with Anaconda. Now, for those of you that are used to using more of a GUI-based approach, your first reaction might be to go to the Anaconda website and click on the installer and double-click the exe or the MacD package and install it that way. That's not what we're going to do, because everything you're installing on things like Paperspace and, well, not so much Paperspace, on AWS, you're going to have to do through the terminal anyway. And really installing stuff through the terminal is easier because people can just say, these are the 5 commands to run to install everything through the terminal. You can copy the 5 commands, paste them all, they're done. There isn't all this like, double click this, click next 5 times, agree to the license, blah, 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 right? So if you're using Mac OS, copy and paste this wget command. If you're using Linux, copy and paste this wget command. And when I say Linux, I include Ubuntu for Windows. Okay, so I'm going to copy that, and I'm going to go across to my computer's terminal, okay, and I'm going to paste it, which is right-click on Windows, and I think right-click also works on Mac, or I think on iTerm too, you can press Command Shift, Shift V. I guess the other thing we could do is, well, let's get it, and then I'll show you how to move it somewhere better. And for those of you that don't live in the US, I apologize for the fact that I just downloaded 0.5 GB in 21 seconds. You're probably really angry at me right now. I know, because I used to live in Australia where that did not happen. So if we now type ls for list, actually let me make this a bit bigger. If you want to change your font size and stuff in the Windows Ubuntu, you can go to Properties and Font. Can you see that okay? One more? Yeah, that's okay. You don't need to see that more. So you can see we've now got this file here. Since we're going to be using this quite a bit, I don't really want to put everything in the home directory. I probably should have put it in a directory called like downloads. So I can now say make directory downloads, and then I can say move Anaconda. Now I don't want to type that whole damn thing, Anaconda, so one of the most important things to know about is tab completion. Type the first few letters, whack tab, okay? And I want to move it to downloads, so start typing downloads, whack tab. Okay, and hit enter. Okay, so up arrow and tab, I guess, are the 2 most important things to know. If you find that tab's not working for you, that probably means you're not using bash. There's a much older shell just called sh, which is kind of the original shell, which doesn't really do anything useful. And so you should Google right now for the name of your operating system, switch to bash. Okay, and it'll show you how to change your default shell to bash. There are also other shells like ZSH and Fish, which are in many ways better than bash. If you're using those, they're largely supersets of bash, so everything to show you should work just fine. Great, so now I can cd, change directory to downloads, and I can, so you'll see this thing is actually, it says .sh, it's actually a bash script, it's a shell script. So to run it, I type bash space and then the name of the script. Okay, so I type bash space capital A. And now notice that things are case sensitive, unlike in Windows. So bash space anaconda.sh, hit enter. Please review the license agreement. Okay, I totally read that. Yes. Accept the license. Okay, so it asks me where to install it to, and by default, you'll see it's installing it to my home directory. This is good, right? Well, you don't want to install it over the top of what we call the system Python. In Linux and Mac, Python is actually used by your computer to do various things. So we don't want to be screwing around with that. So by installing it into your home directory, it's not going to change the way your computer works in any way. So that sounds perfect. I'll just hit enter. So as you can see, it's installing a whole bunch of packages, including things like the basic C library, the basic Fortran library, the basic C++ library. So it's one of the nice things here is that by us all using Anaconda, we have a very consistent set, not just of Python modules, but of underlying, C libraries. It's also really cool. You'll see here it's installing MKL. This is the Intel Linear Algebra library, which is going to make everything a lot faster. Trying to install that on your own is an absolute nightmare, to say the least. So it does a lot of cool stuff. So let's leave that installing. And while that's happening, let's talk about some pros and cons. So I think hopefully for the course we're going to have some really good AWS options. And assuming that we do manage to get some really good AWS options, one of the big benefits of using AWS is that you will be using the exact same environment as most of your employers or potential employers are probably using right now. If they're not using AWS, they're probably using Azure, which is extremely similar. So you'll get experience with using SSH and Amazon machine instances, and AWS is such a rich environment that you can really do a lot with it. So that's one of the benefits of using AWS. Also, they have a lot of different sized machines, and when you sign up, you'll get 12 months of free access to it's the T2 micro size, which is actually not bad. It's plenty good enough for you to play around with non-deep learning Jupyter Notebook stuff. So you can do a whole lot of practice totally for free. So there's some real benefits there for AWS. Having said that, you've got to use the terminal for everything, whereas Paperspace gives you a whole Ubuntu Windows environment in your browser. So if you're really not very familiar with using stuff through the terminal, Paperspace might be a gentler introduction. It is a Linux-based desktop that it gives you, and that's unfamiliar of itself, but at least for downloading things, you don't have to use wget. You can use it's kind of weird. You can click on the browser inside the Windows environment inside your browser to have a browser in a browser, which I guess you could then run Paperspace inside of. Don't do that. To download stuff more easily, whatever. So, maybe sometimes if you're just finding doing everything through the terminal a little overwhelming and you really want to focus on the deep learning, that's one good reason to use Paperspace. Also, for now, at least, they have better GPUs. And then, yes, unit.
So what advice you have for people that have already Anaconda installed on Windows, and should they install it also on Ubuntu?
Yeah, I would definitely install it on Ubuntu as well, because we're going to be like apt installing various packages. Some of the things that we're using don't work on Windows. I mean, Windows is not at all a bad environment for data science. It's just it's not well documented. It's not well supported. You know, so like I think for people who are interested in like building a skill not many people have, I would say becoming good at using data science, deep learning stuff in Windows is a skill worth developing. But you know, I think for the purpose of this course, you've got plenty to learn. You know, just to get through the deep learning stuff. So I would suggest you know doing it in Ubuntu. But I do find like everybody in the course kind of ends up with their own interests or whatever, and I suspect some people in this course will kind of decide like, you know what, I would like to help make a really good version of FastAI that runs entirely on Windows. And I would love to see that, and it would totally work fine, but it would be a lot of work, so got to want to invest in that. Yeah, so then Crestle is the easiest way to get a Jupyter Notebook up and running. As soon as you sign up to Crestle and click Start, the thing that appears in your browser is not an SSH window, it's not a X Windows desktop, it's a Jupyter Notebook. So, in fact, you know, for today, you know, when we get to looking at Jupyter Notebook together, that might be the very easiest way to get going, particularly because that will be a GPU-enabled Jupyter Notebook. So Crestle is the only instant GPU-enabled Jupyter Notebook system I know of. I think, you know, doing stuff on your own laptop is great though, because you know, it forces you to install things and manage things and stuff like that. So you know, we're going to start, that's why we're installing stuff now, and also so that you have something that you can use, particularly the international students don't always have reliable internet connectivity. Yes, you know.
There is some confusion here. So this is a question. Are you installing Anaconda in the Windows Bash?
In Windows Bash, yes.
It's only partially supported. So would Jupyter work?
Yes. Yeah, everything except GPU stuff is going to work fine. This is a full version of Linux. The only thing we're not going to be able to do is to use our GPU. So everything we're going to see today will work fine, whether you're using Mac or Linux or Windows in your own Jupyter Notebook. And so like, and indeed nearly everything you find out there on the internet will work. So if you go Jupyter Notebook examples, for instance, you know, here's a whole gallery of Jupyter Notebooks, and like you can scroll through them, and whatever your area of interest, there's probably a bunch of Jupyter Notebooks about it. So if you're interested in linguistics, there's a bunch about linguistics. Earth science, there's a bunch of stuff about earth science. And so pretty much all of these are not going to require GPUs. You'll be able to run them on your own computer right now. So here we are, IPython notebooks for earth sciences, for instance. Thank you, Ina. So then the final option is building your own workstation. And in some ways it's surprising this should be useful at all, given that there are people professionally running these GPU-based clusters for you. But it's kind of an accident of kind of economics. NVIDIA has 3 classes of graphics cards. They're called Tesla, Quadro, and GeForce. GeForce cards are built for gaming. The close to, very, very close to the best one you can buy is called a GeForce GTX 1080 Ti. And that is pretty close to being one of like the fastest cards you can buy across any of these areas, but it costs like $600 or $700 because it's marketed to gamers. Tesla is marketed to people doing scientific programming, people like us. And the equivalent Tesla card, performance-wise, will cost you about $4,000, $5,000, anywhere up to $10,000. And the difference is not really performance, it's like fairly minor enterprisey features that you won't care about. But on the whole, cloud providers don't provide GeForce cards because one of the things that's hard to do with a GeForce card is like cloud computing. So you kind of have this ability to buy something for $600, which is better than or as good as something that the cloud providers buy for $5,000. And so that's the basic reason why you can put together something at home. You can buy a box for $500. You can put 4 1080 Ti's in it for a couple of less than $3,000, and you now have this like GPU supercomputer, which is like far better than almost anything you can use in the cloud. It'd be much better than the thing that currently costs $15 an hour from AWS. So,
I wonder, did you, after installing, put the path of Python in the bash?
Yeah, I was just waiting for that to pop up.
Oh, okay,
so,
okay.
Yeah.
Yeah.
And you've got a question behind you. Can you pass that back? Okay.
So no, my question was, I don't know if it's changed, but last time I checked, these scientific ones had like much better memory, and I don't know how much higher memory. I don't know how much this plays a role because it wasn't clear to me because they're marketed like, okay, this is 24 gigabytes.
Yeah,
of memory and whatever.
yeah. So what's your name?
Stathis.
Stathis. Stathis. So Stathis is referring to the memory in the graphics card itself, not in the computer, right? And we mentioned that's really important. The 1080 Ti has 11 gigabytes of memory. A lot of the Teslas have 16, and a couple of the newest ones have 24. Sometimes that can help, although interestingly, at some point we'll learn a trick with PyTorch, which removes a lot of that convenience. But yeah, I mean, if you're doing something where you're kind of limited by memory, in other words, like your GPU is not 100% pegged in terms of the processing time, it's really spending all its time getting stuff into and out of memory, then that can certainly happen, and being able to use bigger batches will help a lot there. Yeah, it helps, but honestly, 11 gig is pretty great, actually. Can you pass it over there?
So do you intend to use Jupyter notebooks on AWS and Paperspace, or do we just prototype on our desktop and write some Python scripts for it?
Yeah, I use Jupyter Notebook, and we'll get there. I use Jupyter Notebook for everything. Like everything I write in Jupyter Notebook. And if I later on decide I want to, use that as a backend to an API in Flask, or I decide I want to try 50 different versions of it in a script, I'll click download as Python script and edit it from there. As you'll see, the kind of ability to work interactively and experiment in Jupyter Notebook is a really effective way of building up, something in machine learning.
So do we have to install Anaconda on those machines too?
Yeah, we'll get there. Yeah, the short answer is the Paperspace Fast.ai image already has it. installed. Cressel already has it installed. And we will be providing a AWS AMI, Amazon Machine Instance, which has it installed. So in general, the only time you're going to install it yourself is on your computer, and if you get to it on your home deep learning rig, or at your workplace or whatever. So like, we're not going to be showing in, other than this introductory optional workshop, we're not going to be showing people how to install Anaconda because this is like an optional thing. You don't necessarily need it, but for those of you that have been enthusiastic enough to spend your Saturday here, we wanted to like show you how to do some extra stuff, I guess. Chuck that back here. I have to find something more sticky. Okay, so at the end of the install process, it asks me this very important question. Do you want the installer to prepend the install location to path in home jhoward.bashrc? Now there's a lot to unpack there. Anybody who's at all familiar with Unix-based systems, this will be all immediately obvious, so I apologize for going through this slowly, but let's talk about it. Home jhoward, that's my home directory, which, remember the shorthand for it is tilde. Okay, and if you just type cd, it'll take you there, or cd tilde will take you there. Anytime you type tilde, it will expand to home jhoward. File names that start with a dot in Unix-based systems are configuration files. So they're files used for other programs to know how they should behave. They generally end, so they're generally dot, then the name of the program, and then RC. So in this case, this is a configuration file for bash. So anything in .bash RC, and the configuration files for you live in your home directory. So this is a configuration file for bash for you. So this wants to add a line to your bash configuration file, which is going to prepend the Anaconda install location to path, capital or caps path. All caps, by convention, generally refer to environment variables. So environment variables are, they're like cookies in a browser, but they're for your shell. They're basically key value relationships. And different keys have different meanings. The key, all caps path, has a very special meaning, which is anytime you type a word and press enter into bash, it looks through every directory in the path environment variable to try and find that program. So you want to be able to type Python and pip and conda, right? If you type those things and it can't find it in your path environment variable, it'll say not found. Okay, so that's why we want to say yes. Now, as soon as we say yes, now if you type Python, it's not going to find your system Python or your old Python 2.7 or any Python you've been using before. It's going to find the Python we just installed. And just to check that, we can type which Python. And this says, if I type Python, what does that really mean? And, oh, okay, it's not going to do it yet. Because the bash configuration file is only read when you first run bash. So there's two things I could now do. I could either log out and log back in. To log out, you can type exit, or you can press Control-D. And notice if you're using a Mac, when I say control, I don't mean command. I mean that control button that you never use. That control button you never use is what you use for all of your terminal shortcuts. Okay, so Control-D will log out. And so then I can log back in. And now, and remember I can press up arrow to bring back the command that didn't work. And now it tells us that. Okay. The other thing I could have done is to rerun my bash RC, because it's actually a script. So I could have typed source.bashrc, and that would also rerun the bash RC. Okay, so what if we want to use your other Python you could edit your .bashrc to remove that extra line that was added. So to have a look at a file, you could cat it. Right? So type cat.bashrc, and you'll see at the bottom there's that line. And so you could put a hash sign at the front of it to comment out that line. Better still would be to use Conda's environments to install a Python 2.7 environment if you need one, and then you can switch backwards and forwards that way. But this isn't something I'm going to teach you how to do. It's up to you to figure that out, and you can talk about it on the forum. But for now, if you need to have access to your old Python and you don't want to learn how to do that, just comment out the export path at the end there and log out and log back in again. So at this point, we can use Jupyter. So if I type Jupyter Notebook, remember I'm using tab completion, Jupyter Notebook, hit enter. And it says, okay, it's running. And so it says we can copy and paste this URL into the browser when we connect for the first time. So I will do that. So so in Ubuntu for Windows, you can double click on it and just press enter to copy it. In item 2, it's Apple Shift C. So I can now paste that over here. And there we are. I have Jupyter Notebook. Okay. Now, Jupyter Notebook will list the contents of the current directory you're in, right? And so what I normally do, and so I'm going to press Control-C to stop it. I Control-C twice, actually, to stop it, because the first one checks. I'm going to say make directory NBS for notebooks, and then I'm going to CD into notebooks, and then I'll press up arrow 3 times to bring back Jupyter Notebook, and press enter. Okay, and then you can see now it's updated and said, oh, this is now empty. So this is now a directory that if I run Jupyter from here and I create notebooks, so new notebook, you can see it's just, that's all that's there, is my notebooks. And back over here, you can see my notebook has appeared. Okay. So does anybody need, well, let me give you some time to make sure your Jupyter Notebook runs and that you can connect. Okay.
So if we have Anaconda installed in Windows before, do you still recommend we install it using Ubuntu?
I do, yes.
Okay.
Yes. But it'll make life easier for you.
Okay. And between Jupyter Console or Jupyter Notebook or something like Spider, which one would you?
I would use Jupyter Notebook,
Okay.
at least for now. You know, I would strongly suggest using the same tools that we're using for now, and then like later on in the course, if there are tools that you're more familiar with that you think like, okay, I now know enough about the tools that Jeremy thinks I should try out to try these other ones, then you can, you know, make a more informed discussion. And then it'd be great to like post to the forum and say like, hey, you know, I've really liked Spider and here's something I like about it now that I've tried both. So for example, Emacs users, there's some really great things that will interact with the Jupyter Notebook kernel via Emacs. And so Emacs users will probably find that they'll get a lot of pleasure out of trying that out. PyCharm users, you'll find there's actually a part of PyCharm is something that can interact with Jupyter Notebooks. So there are actually some interesting tools out there, and I'm not saying they're not worth trying. I'm just saying, yeah, I would suggest starting with what we're using here. You know, maybe lesson 4, lesson 5. If you feel brave, you know, try some other stuff too.
Yeah, thank you.
You had called one of the things you typed in bash RC, but my computer says bash underscore profile. Is there a big difference between the two? So
No, there's a very small difference between the two, and thank you for your question. What was your name?
Divya.
Divya. How old are you, Divya? Can I ask?
14.
14, okay, that's great. So last year we had somebody who was 15, so I think you're officially our youngest student now. Yeah, you should use whatever it tells you to use. They're basically, one of them is run only when you actually log in, and one of them is run even if like a process logs in automatically, basically. And different versions, you know, it's quite possible that your setup might be set up to only use one and not the other one. So yeah, thank you for the question. Great. Okay, so here from Prince Grover is the steps necessary to switch back and forth between Python 2 and Python 3 if you already had Python 2 installed. Now, one of the things we're going to be doing, in fact, I'll set it up. In fact, maybe you can set it up for us, Yannet, is set up a wiki thread. One of the nice things about Discourse, this forum system, is we can create, admins can create something called a wiki thread. And a wiki thread is something where everybody can edit the post. And what we do for every lesson is we create a wiki thread so that then you can go in and add, you know, links, tips, stuff like that to the wiki thread. So Yanet's going to create one now, and you should find Yannet in the little tool icon. There's a make wiki thread button after you've created it. And so then, for example, Prince Grover, you can go in and copy and paste your how to switch between Python versions into the wiki thread, and it becomes like one place we have for that information. Okay, so that's useful information from Gokul Nath TS. Thank you. So this is from Paperspace pointing out, yes, when you delete an hourly machine, you lose your storage fee. I had no idea. Yeah, so Conda Python won't mess your current Python at all because we're installing it into the home directory. So path isn't a command, path is an environment variable. If you want to learn more about it, just Google for path environment variable. It's an important thing to understand. Yeah, so Chris Palmer points out that Windows also has a path environment variable, and the Ubuntu version doesn't have any relationship to it, and that's right. So for you Windows users, this Ubuntu thing is very separate. You know, it doesn't really share almost anything with your Windows box, and that's by design. You can access all of your Windows files, and generally speaking in Linux, all of your external drives are in /mnt. These are your mounted drives, and Windows will automatically mount all of your Windows drives under /mnt. So you can access all of your Windows stuff from Linux and modify it and create links to it and so forth. So they're not totally separate, but you know, other than that, the ability to share files in that way, they're pretty independent. We're not going to be talking about PyTorch today. about AWS later. Okay, you can't use Linux Anaconda under Cygwin. Cygwin is not a true Linux. It's a kind of a weird little subset. So if you're using Cygwin, your best bet would be to use the Cygwin setup to install Cygwin Python, and then use pip to install stuff. So yeah, that's going to be a little inconvenient. Yeah, also if you don't have Windows 10, that might be a good reason to just use the normal Windows Anaconda even. Might be easier. Yeah, so Sri, please don't use the graphical installer. Please use the wget version that we suggested. So just uninstall it and start again. Okay, don't use SLI, Gerardo, for CUDA stuff. It doesn't help. I actually don't know if the public IP on Paperspace is secured or not. I'm assuming it would be, but maybe somebody can look into it and check. But yeah, I would suggest activating public IP if you can afford the $3 a month. Do you need to dual boot Ubuntu for Mac? Probably not. Most stuff is pretty well supported on Mac, data science-wise. Okay, Sanyam, Yannet is going to show you how to use Git to get access to the FastAI repository, and you can go ahead and read all of the notebooks for reading ahead if you wish to. So you'll see you can get your own overview that way. And in fact, in Paperspace, do we already have it, Yannet?
It's supposed to be.
Yeah, so if you're using Paperspace, you might find that the FastAI repo is already there.
I'm not sure because my computer was before, the one I created was before yesterday.
Oh, and it's already shown the git command. Oh, that's good. GitHub Student Developer Pack for $150 worth of credits. Okay, that's good to know. Great. Great. Okay, so does anybody need help getting Jupyter Notebook up and running?
I feel like I could use a bit of help right now.
Could you put that close to your mouth?
Oh, it's mine. Yeah, thanks. Right, so right now, what I have is what I did was I installed I went on Anaconda.org and downloaded Anaconda Cloud, which is the main link what they had there. And right now,
don't do that. So undo it and go back and use the wget command and the bash command that I showed.
All right. It's like, what was the command again?
You can find it in the Google Doc.
Right. Where's the link to the Google Doc?
The link to the Google Doc is in the forum.
All right, I'm trying to. Right.
So if you go to the in-class discussion, it's the very first post. Okay?
All right, one second, in-class.
Yeah. So why don't you have a look at that and we'll come back to you. Can we have the mic back?
Right.
Thank you.
All right. So success, I was able to get the Anaconda set up.
Yay.
And so now I'm in the Jupyter Notebook.
All right.
Where it opened the window.
Yeah.
Is there anything else that I would need to do to get set up?
No, that's it. So Yanette's going to take you through how to use it in a moment. Yeah. Very nice catch. And we're all going to get plenty of experience at throwing the green box, don't worry. It's part of our skills as well. It's very soft, so if you hit somebody on the head, it's totally okay. Okay. Yanette, you're going to do from learning to use Bash and Git onwards, aren't you? So, what I might do is I might go for another 15 minutes or so, then we might grab some lunch and then come back for the Yanette's bit. Okay. So here's our Jupyter Notebook, and what's happening is behind the scenes, there's this server running, So we're going to this a server on localhost. So localhost always refers to your own computer, :8888. So that's referring to the TCP/IP port, and so running on that port is a server. And one of the nice things is you can create as many tabs as you like pointing at that server. So if I open a new tab and go to that localhost 8888 again, I've got another one. And I can create as many notebooks as I like, have them all running at the same time, all running from the same browser, no problem. Switch between them. It's a nice, proper multi-process server that manages all that stuff automatically for you. The thing that pops up is called Untitled by default. So if you click on it and rename it, we could say Workshop and press Enter, and it's been renamed. And so behind the scenes, you can see that it's renamed here, workshop.ipynb, as in IPython. It used to be called IPython, not Jupyter, so IPython notebook. And you can also see back over in your directory. Okay, so, and for those interested, the notebook is just a bunch of JSON, right? It's just a text file, so you can check it into version control, whatever. Right? So the stuff that I can now type in here is any Python command, and whatever is returned by that command will be printed. 1 + 1. Okay? So you press Shift-Enter to submit this cell to be executed. Right? So, hello, Shift-Enter. Any Python will be fine, including things with line breaks. And tab completion works. All right, so tab, down, enter. Everything that's on the toolbar is also accessible with keyboard shortcuts. So to get more space and to force you to learn the keyboard shortcuts, you can turn the toolbar off. The thing at the top takes up a whole lot of room for no good reason, so I normally get rid of that as well. Okay. Then in Chrome, you can hit F11 to full screen it, and this way you've really got quite a lot of room to do your work. If you're using Microsoft Edge, it's Windows Shift-Enter to full screen. And I think Firefox is also F11, if I remember correctly. So yeah, so here we are, and you can go back and hit up and down to go back to previous tabs, and you can hit enter to go into edit mode. You can change them, shift enter to rerun them, and then you can rerun the command and it works. So basically, this Python process it's connected to behind the scenes, every time you run a cell, it's kind of updating that Python process's list of variables and so forth with whatever you've done, whatever functions you've created, whatever classes you've created, and so forth. We don't really have time to talk about it today, but I do want to point out that PyTorch does use the object-oriented features of Python a lot. So if you're not familiar with them, please spend the next week learning about them. Basically to create a class, you just type class, you type the name of the class. Generally we use camel case in Python. And then any functions you now create in here are methods, right? So okay, so shift enter, that's now a class. I can instantiate it by just calling it. I can call methods on it, and tab completion works here too. So h.tab will auto-complete to the only method it's in it. Okay, one weird thing about Python objects is every method you have to tell it that it takes self, and there we go. So if we want to then create a constructor, one with Python is like an ugly language in many ways. You have to use a special method name to create a constructor, which is pretty much everything that's special in Python has underscores on either side of it. So underscore, underscore, init, underscore, underscore. If you're a Python inner circle person, you would call that dunder init. So if you hear dunder init, they mean underscore, underscore, init, underscore, underscore. So this is the constructor, so I could be like, pass in like what to say, and I could say self.to say equals the thing I passed in. Here's a really neat little Python 3 trick, is you can put things inside curly brackets in a string, and it will interpolate that into the string. You need to make sure that you put the letter F at the front to say this is a Python 3 format string. So now I could say, all right, I want to say hello to Jeremy. Okay, so that's as much as I'm going to show you about Python. But you're going to need to know everything that's there in order to do PyTorch. How to create a constructor, how to set attributes, how to create methods. That's about it. If you want to go deeper, which I hope most of you will, and really understand and dig into the library that we're building, you'll also need to understand inheritance. Okay, so you're keeping an eye on the questions for us, Jeanette? Yeah, that's fine. Just let me know if anybody has any questions that aren't getting answered. All right, so the stuff I particularly want to talk about for Python is, it saves itself pretty much from time to time. But if you press File, Save, and Checkpoint, that will actually create it creates a single checkpoint for you. So if you screw something up and want to go back to when you last said save and checkpoint, you can say revert to checkpoint, and you'll see when it was if you did that checkpoint. Okay, so that's how it's kind of like a single backup it creates. And also by doing save and checkpoint, it ensures that it's saved right now. The shortcut key for save and checkpoint is just the letter S. Right? Now, obviously, there's no point, like if you're in edit mode, you press S, it puts an S up here, right? To get out of edit mode, just hit escape, right? And now I'm in command mode. right? Now S means save. If you press H, you get this wonderful, magic, awesome screen. And every single one of these keyboard shortcuts is useful. So I would suggest, like, between now and the start of class, try and learn 4 a day and like play with them. Like, the only way to learn a keyboard shortcut is to like use it 5 times that day, you know? So I'll show you a few I really like. C to copy a cell, V to paste a cell. Notice there's no control here, it's just C and V, and then X to cut a cell. So if I want to move this cell down, X to cut, V to paste. Okay? Or if I want to copy this one, C to copy, V to paste. Okay, so you can, these all work cell by cell. Or if you hold down Shift and press the arrows, you can select a few cells. And now if I copy and paste, it pastes all of those cells. Okay? So to get rid of them, I would select the whole lot and then X to cut. Okay? Something else I find very helpful, and a lot of people don't know, is let's see if I can find it, the Shift M keyboard shortcut. So like quite often, if I've done things one cell at a time, later on I kind of want to run them all together all the time. I can select them, Shift M, merge. Okay, so it turns 3 cells into 1 cell. I find that really helpful. And then the opposite is Control Shift hyphen splits. So you can turn 1 cell into 2 cells. So anyway, there's lots of these shortcuts. They're all helpful. Often you want to create a new cell underneath this one. So B for below creates a new cell, or a new cell above this one, A for above. Okay. So pretty much everything that you would know from text editors you can kind of do with cells. One of the nice things about Jupyter Notebook is you can put in not only code, but also documentation. So to put in documentation, you hit M for Markdown. Who here is somewhat familiar with Markdown? Most of you. Okay, so Markdown is a super handy way of typing plain text that gets converted into formatted text. So I've just pressed M to convert this to a Markdown cell, and you'll see it doesn't have a little in and a number here anymore. That's how I can see it's a Markdown cell. So stuff I type in here is going to be turned into Markdown. So I could create a heading, and then I could create a list, and I could create a link. Okay, and now when I hit Shift Enter, it won't execute it, but it will render it. You can put videos, pictures, just about anything in here, right? And this is amazing because you can share it with your colleagues and they're going to see exactly what's going on. You in 6 months' time won't hate old you because you'll actually know what you were doing and why. And so like when I create notebooks, even if it's just for me, I tend to like imagine that I'm going to be teaching some of these things. Like I try to really show what's going on as I do it. I put in links to like where did this piece of code come from, what paper am I implementing, whatever. So, you know, I think that's a super helpful thing. And you know, doing things like inserting a heading, there's a shortcut key for that. You know, just hit the 1 key and it creates a heading level 1 or 2 for second level, 3 for third level. There's lots of handy little bits and pieces. Sometimes the kernel, i.e. the Python process that's running behind the scenes for this notebook, which is called the kernel, might get stuck. Maybe because you created an infinite loop. Maybe because your GPU got confused. You can stop it by pressing II to interrupt kernel, or you can go kernel interrupt. And that's exactly the same as hitting Control-C to that Python process. It'll stop whatever it's doing. Okay. You also may get to a point where you've accidentally created a million variables and used up all your memory. You want to restart the kernel, like basically create a fresh new kernel. So you can say kernel restart. Right? It won't change anything the way your notebook looks, but behind the scene, everything you've created in the kernel is gone. So if I say restart, right, and I now say print hello, it's not there. Okay, so I would need to go back and rerun the command. So I'm going to just go put my cursor there, hit Shift Enter, right, and now it's there. Okay, so that's how to kind of escape if things get bad for some reason. Nat, is there anything else you feel like notebooks is useful to know about for starting? If anybody has tips, yeah, tell us on the forum. Have you created the wiki thread?
No, because I don't know how.
Okay, so create the thread first, and then after you've created it, you should find a little spannery icon where you can say make wiki thread, and then you could paste that into the in-class discussion. All right. Yes.
What do you recommend for learning Python object-oriented portion of the Python basically? Class and interfaces.
I actually have no idea. If anybody has recently done that, could they maybe mention on, what was your name, sorry?
Nahid.
Nahid? Maybe they could suggest some resources to Nahid. I did include in an email that Mindy sent out a list of like places to learn Python from, and there was certainly a section there about Python OO. This is like the thing I'm worst at teaching, because I've been programming since I was 7. It's like it's been such a long time since I've had to learn these things, so I'm kind of terrible. So hopefully some of the other students will have suggestions.
I'm familiar with object-oriented programming, but not in Python, so
Yeah.
I wouldn't like.
Well, okay, in that case,
like,
I remember
similar to STL. What are the things?
Yeah. Okay. It's if you've ever used Perl, it's very much like Perl's OO. It's way, if you're obviously a C++ programmer, I'm guessing since you mentioned STL, it's way easier.
And Java.
It's way easier than C++. I mean, basically, I can probably actually explain in 30 seconds what you need to know if you're an experienced OO programmer. When you create an object, it's just like C++, you pass in the name of the class. The arguments that you provide are sent to a thing called dunder init. Every Python method, including dunder init, automatically gets one additional parameter. You can name it anything you like. If you call it anything but self, everybody will hate you. So in practice, we always just put self. Well, actually we don't. In practice, I always forget to, and then I try to run it, and then it says you're missing an argument, and then I put self. Attributes, i.e. properties, I guess, well, fields, really, are created automatically. Anytime you go self dot something, it creates a field, which in Python are called attributes. So here is now a field of attribute called to say, and it's set to the thing I passed it. Honestly, that's about it. If you want to inherit, you just put the name of the class to inherit from here. So let's say I wanted to inherit from Greta. That does not automatically call any superclass anything. So if you now want to call the superclass init first, there's a special super function that returns a reference to the superclass, so you can go super underscore init. I think that's about it. There's a couple of other things we'll cover in the course itself, like static and class methods. But in terms of stuff I'm assuming you know, I think that's all. Did you have any questions about how that bit works? Because if you understand how that bit works, then I think we're done. Great. Oh, I suppose it's not. And as I say, sometimes when people ask me a question that assumes some fairly advanced background, like C++ OO programming, I will answer it. But if you don't have the same background, please don't assume that you needed to understand that explanation, right? It's just I want to, since there is a 30-second answer, I thought I would give it. If you don't have that background, then yeah, Google for Python OO tutorial and spend some time on it. Tell us what you find useful. Right. So the thing I think is just about most underutilized in Python amongst like all programmers is comprehensions. Anybody who has done functional programming will be familiar with this idea of a way of programming where if rather than running a loop and saying for each thing in loop, do something, instead we say, here's a list, do something for everything in the list, which we would refer to as a map, generally speaking. If you haven't, and in fact, this approach to programming is becoming very popular in modern JavaScript. So anybody who's doing modern JavaScript is probably familiar with this kind of idea. You might have used a library like underscore.js or something like that. C# programmers will certainly be familiar with this because it's how LINQ works. The new Java Streams API is basically this. So like anybody who's probably used somewhat modern languages or somewhat modern versions of languages and have kind of stayed up to date will probably find this extremely familiar. For those of you that haven't coded for a while, or maybe are kind of stuck with using some older languages or versions, some of this might be less familiar. But it's a whole way of thinking about coding, which is kind of taking over the world. And particularly for numeric programming, it's particularly useful. So let me explain by example. So I'm going to create some variable. And to create an array, we normally just stick something in square brackets, right? Okay, so the first thing I'm going to point out is often I want to create something and print out its value straight away. You'll often see my notebooks, therefore, look like that. So most Python programmers don't use semicolon. It's kind of like strongly recommended against. You'll find that these recommendations about how to structure your Python is called PEP8. I don't just ignore them, I like destroy them with a flamethrower. Because I find that like the right things to do for data science prototyping are very different to the right things to do for like creating long-term maintainable code bases. So like don't get angry at me when I don't do PEP8 things. I'm creating Jupyter notebooks here, I'm not creating libraries. So this idea of like creating something and immediately printing it, I do it all the time, okay? So what if I wanted to create the numbers from 1 to 5? Well, I could do it like that. That's kind of boring, right? So I could do something like another thing I do a lot of, which real Python programmers hate, is I put things on the same line. If I'm doing a single thing in a loop, I generally do it in a single line. So again, don't hate me, that's something that I think is reasonable. Okay, so I could do that. But I really wanted to create like the list, not just print it out, because later on I want to multiply it by 2 and save it to a pickle file and turn it into an image or whatever. So the kind of old way would be to go like that. Right? And notice I just typed A at the end, it prints it out automatically. You're most welcome to go print A, but it's nice to get used to doing this approach. It's just so much quicker and easier. So what I'm doing here is two things. I'm saying I've got a range to loop through, which is in this case from 0 to 4, and I've got an operation to apply, which is the operation, the operation add 1. Okay, so a list comprehension lets me do those two things at the same time. So it basically looks like this: for I in okay, this first ... is where you put the operation you want to do, which in this case is add 1. The second ... is where you put the list of things you want to do it to. So in this case, the thing that I want to do it to is range 5, and the thing I want to do is add 1. Okay, so this is not a for loop. There's no colon, right, after the for. It looks a lot like a for loop, but it's not. It's not in any way syntactically related to a for loop. It's called a list comprehension. And it creates a new array. And it's got a very specific structure, which is thing to do, thing to name each thing I'm in the list, and some way of getting a list of things. It doesn't actually have to be a list. For those familiar with Python, any kind of generator. So if I run that, I get the same result. Right? And so list comprehensions are super handy because they take a list, or a generator to be precise, and they turn it into a new list. And so you can stack these things together to create a pipeline of data manipulations, right? So if I had like, well, I mean, so we could do it right now. So we could say like, I times 2 for I in A. Okay, so now I've got two things happening to everything in the list. And because this is any arbitrary Python operation, any Python code, I could do a function. Return it times 2 plus 1. We could do it all in one go, say. And so now don't forget tab complete. Now notice this I in here, that the scope of this I is very limited. It's just inside this list comprehension. So you can't play with this I again afterwards, right? It's just a placeholder for the list comprehension. So I will be using this in the course all the time. And indeed, many, many data scientists use this all the time, because data science is basically about manipulating data. We have like a whole bunch of items of data and we want to do something to it to create a new list. And indeed, you know, a lot of you will come across the idea of MapReduce, you know, which is kind of the idea things like Hadoop are based on. It turns out this idea of like mapping a list to something else is a pretty powerful step in general. it's probably worth mentioning reduce as well. A reduction in computer science parlance is something that takes a list and turns it into a single item. And so the most simple reduction is probably sum. Now sum by default takes a list and sums it. But actually it's a generic reduction where we can do what's somewhat generic. This is actually something that's going to insert plus sign between things. And so what we could do is we could say, let's turn this into a string. Right? So A is now a list of strings. And so this doesn't quite work, right? But we can tell it, don't start with 0, but instead start with an empty string. Let's start with an empty list. Okay, let's make this into a list. There we go. So now I've got a list of lists, and I'm starting with an empty list and concatenating them together. In general, there are 3 main pieces of this kind of functional programming style. There's map, which is what we learned first, it's basically a list comprehension. There's reduce, of which sum is a specific example. We're reducing A by applying the function plus, starting with an empty list. Okay. And if you're interested, you can look up Python reduce to see how to do general types of reduce. And then the only other piece is filter, which is to only do it on a subset. We can do that in list comprehensions as well. So let's say we wanted to, let's go back and make A this. So A is 1, 2, 3, 4, 5. In this case, let's say we only wanted to do it for even numbers. So I could say, so the second thing you can put into a list comprehension is an if. This is not the if statement in Python. It's not the if function in Python. It's just the particular syntax we use to create a filter in a list comprehension. And this is where we get to say, only use a subset of the list. You can say if I mod 2 equals 0. For those of you who don't know, percent means mod. So divide by 2 and see if the remainder is equal to 0. And so that's going to give us the even numbers, multiply them by 2, add 1, stick them in a list of lists. Okay, so this idea of map plus filter is everything that a list comprehension can do. But it doesn't sound like much until you realize that enormous amounts of programming only do those 2 things. And then at the end, often we will do some kind of reduction. So something which a lot of people don't realize is we can actually also do dictionary comprehensions. And a dictionary comprehension is identical, but it creates what Python calls a dictionary, or in other languages you might have seen called a hash or a hash table. In C++, I think it's called a map, something which is basically a key to value relationship. So normally dictionaries look like this. Okay, key colon value, comma, key colon value. So we very, very often want to create dictionaries. A really good place, the example of where we're going to use them a lot is in natural language processing, which we'll be doing quite a lot of in the course. One of the things we often do is create something called a vocabulary. The vocabulary is just a list of all of the words that we're currently working with. So there's a vocabulary of 3 words. And what we generally do is we take a sentence and we convert it into a list of numbers, where the number is the index into the vocabulary. So every time we see the, it would become 0, a would become 1, u would become 2. So how would we do that? Okay, well, we want a map or a hash or a dictionary from the word to its location in this array. So let's call this V for vocab. Okay. And another place I write things in a very different way to software engineers is I often use short mnemonics. Right? So you'll find, we'll talk about this more during the course, but mathematicians tend to use obscenely impossible letters, including Greek letters, to describe things. Java programmers use 3-page long variable names to describe things. I try to go somewhere in between. You know, like there's definitely there's good reasons to use kind of short things for things that we kind of all understand, because if it's short, you can kind of see it in one little package, and we get good over time at recognizing familiar structures, and it becomes harder when they're long. So that's kind of why mathematicians tend to use these single letters. So you'll find I often use either a single letter or a small abbreviation, and I'll introduce it with a mnemonic at the time, so I'll say V for vocab. Feel free to use your own mnemonic, or if you want to know why I called something a particular letter, ask me, because it's much easier to remember when you know why it's called something. Okay, so here's our vocab, V. Yes, do you want to grab that?
1:15.
Wow, how did that happen?
We want people to go into the stage.
Huh?
At least we want people to the stage to the computer.
Yeah, okay, great. Thank you.
But you should fit that.
Okay, thank you. Time flies. Shit. Okay, so to turn this into a dictionary, we can create a dictionary comprehension, which looks really much the same as what we saw before. There's a for something in something. Now in this case, we're going to have an index and the actual word. And in Python, if you type enumerate and a list, it returns pairs of the index of the thing and the thing itself. So, in fact, if we just show you that by creating a list comprehension, right, so that's basically what enumerate returns. So to create a dictionary, we can just turn those backwards. So we can say W:(I). And this is what a dictionary comprehension looks like. It's identical to a list comprehension, but instead it's in curly brackets and it's reversed. And there's our dictionary. Okay, so that would be something that we can now use to convert all of the words into indexes. Okay, so my last thing is NumPy. I think I'm going to skip pandas today. Okay, so the one other piece to know about is NumPy. NumPy is used to create arrays, and the kind of arrays which PyTorch would call tensors. In other words, arrays which are kind of rectangular in shape rather than jagged. It's a library, and everybody imports it as NP. Even in the docs, it's called NP. So import NumPy as NP. So you can create a NumPy array by saying np.array and passing in some Python list. Okay, and so it looks just like the list, and you'll see though it's got the word array around it. NumPy arrays are fast because rather than being stored as a list of Python objects, they're stored in basically the same way as C. They're stored as raw bits next to each other, right? And so we can multiply them by 2, for example, and it's going to apply that times 2 to everything in that array. And it does that not by slowly looping through each thing and looking up the object and finding it in memory and doing it and blah, 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 but instead it grabs the whole block and sticks it all into what's called a SIMD register. So it basically can do up to 8 of these at a time, and they come straight back. So the difference in performance between NumPy code and Python list code will be hundreds or thousands of times faster. And of course, it's less to type because you can type A times 2, whereas in Python you'd have to go either a list comprehension or a for loop to do the same thing. Every data science library basically uses NumPy, including PyTorch. So like all the stuff that we're going to feed to PyTorch is going to be NumPy. So what can you do with a NumPy array? Well, type A, press dot, hit tab, and you'll get a sense of it, right? So anybody who's like a C# LINQ programmer or Java Streams programmer or something like that will be familiar with a lot of these things, but it goes even further. You know, everything you can do to a list, everything you can do mathematically to a matrix or a vector, you know, you'll see that they're all here. Okay, so like it's fun to kind of play with some of these and just see what they do, right? So they don't, obviously, they don't have to be integers. They don't have to be positive. Okay. So a.round. Now, when I type a.round, what's expected next? Here's a really important Jupyter tip. Press Shift Tab. Shift Tab. And it tells you what's expected next. So how many decimal places? So by default it's 0. There it is, right? And if you press Shift Tab 3 times, it actually brings up the whole documentation in a whole separate window. So Shift Tab is great. So given the time, you know, there's not much more I need to tell you about NumPy now, other than here's how you import it, here's how you try it out. It's got great documentation. We're going to be using it all the time, so you want to make sure you're comfortable with like multiplying things together and subtracting things and, you know, just basic stuff like that. So think of something you might want to do to numbers mathematically and see if you can figure out how to do it.
Hello everyone. Hello. Hi. I apologize because I don't know how to use this computer, so you see me trying to, but I'll do my best. So you know, one thing I think we want to get out of today is to try to get you with SSH to AWS and to potentially also Paperspace. So I think I'm going to start there, and then I'll go back and forth to tell you other topics that we have to cover. I put a few pointers on this presentation that I just shared with you. So if we don't get to get everything, you guys have some stuff there. Okay, so let's get going. So I'm gonna start with SSH first, and then I'll go back and forth. Maybe let's do like Paperspace before we do Amazon, because Amazon is gonna take a little bit more time. For you who has the Paperspace computer already, if you have the public kind of name of your computer, like in my case is this number here, 65 49 54 76. Okay, you may try right now. So before doing anything, you have to kind of run this like command that actually no. First of all, you can just try to completely SSH to your computer right now, and then you provide the password, right? That's how you're doing it right now. Okay. So the way I want to make it set up is that if you have so that you don't need a password to get in. Okay, so you get SSH keys, and then you're not gonna need a password to get in, so to authenticate. Okay, should we do that? Okay, so so the way you do that is that you run, and I can run it, or I can just basically talk about it, and if you guys get into trouble, then we can think about what happens. So basically you run this command SSH key generator -t RSA. Okay, so you can run that right now on your computer. Okay, and you're gonna get 2 directories out of that. Should I just do it? Let's just do it. Then you're gonna see that I'm not allowed, no, SSH kitchen. Okay.
Control C.
Control C. I did, but okay. Okay. So it's gonna try to save it to Jeremy.ssh directory. So because I don't want to override his current key, I am just going to type the name here. But you can just go ahead and okay. You don't need a paraphrase, or at least I don't use any paraphrase. I don't use anything. So I got this. Okay. So if I do ls right now, I got these 2 directories. These 2, directories, ID_RSA and ID_RSA.pub. Okay. So what I'm gonna do right now is that I'm going to send my public key, which is the one .pub, to my computer over in Paperspace. Okay. And then I'm gonna be able to SSH in without any authentication, or no other authentication. Okay. So the way that you usually do this is that you put these 2 keys under .ssh. So you make a directory called .ssh. Yeah.
Just to clarify something here, Yanette's currently typing this into her laptop's bash, not into Paperspace or AWS bash. So this is creating a unique password, effectively, a key on Yanette's computer. And we're going to be copying half of that later on to the remote computer, so it knows that it's us, and we'll keep half of it effectively on our computer. So just make sure you're typing this into your bash.
Okay. Yeah, so basically like this is all in your computer because you need to communicate to another computer. So one of them is going to be your private key, which is going to be with you, and the other one is your public key. And you can take this public key and use it in multiple computers to do the same, or at least I do. I don't know if it is, I do all the time, reuse the same pair of keys for different things. Like if you use GitHub, which we're gonna talk about later if you have time, you can reuse that key for SSH into GitHub, for example. Okay. So, okay, so let me go back here. Okay, are you guys were able to get the two key pairs? Fine, yeah. Jeremy, could you just throw the ball over there? Yeah.
If I've done this process before, can I use the keys that I
Yeah,
have?
you can use the ones you have. Yeah,
Okay.
yeah, yeah. So okay, yeah. So okay, so I usually basically get those keys into the .sh directory. So I usually have them there. Okay, and then you can paste and copy. Okay, so don't paste and copy what you have here because you will be trying to send that into my paper space, right? So remember to, so what are we doing here actually? Let me just tell you this. So cat is a Unix command that is basically just showing the inside of your document. I can do a cat, I don't know, actually, let me go over here and just show you some, if I can do cat here, cat ID dot, okay, so this is just showing you the inside of a document, right?
And just to explain here, Yannette's not showing you anything that she shouldn't be from a security point of view. That .pub file is the half of the password, which is actually public. The pub stands for public. This is the public key. The other file, called ID RSA, don't show people. That's yours. So there's this cool mathematical trick where we put the public key on Paperspace. So nobody at Paperspace ever knows our private key. And there's a special mathematical function that they use basically that they could only solve if the public key there and the private key here match. This is the cool thing about public key cryptography. So it's kind of like counterintuitive, that we actually never share our private key with anybody. We only share the public key.
Mm-hmm. So basically what this line of code is basically doing is like sending your public key to that computer. This one is mine, so remember to change all of this from your public IP, okay? And then it's making a directory on that computer called .ssh, and it is adding a file with your keys inside that is called authorized keys, okay? So I'm gonna try to, copy all of this, and I am going to, okay. So, so I already did that, so I'm not gonna do it because then I'm going to mess up my keys in Paperspace, but I would like you guys to do that and tell me, then we have to do something, we have to do one more thing to make this work. And I realized I didn't put it here, so yeah. So are you guys able to do it? Anybody having problems? Yeah. It's my IP, right? So you have to change that for yours because you have to put your own. So you have a Paperspace computer. You probably got, if you have a Paperspace computer, you probably with an IP, with a public IP, you got an email from them with your IP and your password.
Oh, okay.
Right?
Yeah.
So you change. In that line, you change your IP from your IP, and then you have a password right now. So you're gonna run this, and then it's going to ask you for your password.
Okay, correct.
Okay. I've been using a Mac for the last, I don't know, 15 years. Yeah.
That's the password. So you should change it.
Okay. So by the way, there is a tutorial here. It's on the bottom of the page of kind of explaining this in more details. We need to do something extra for this to work. Let me, okay, no, never mind. I'm going to do that. Okay.
So if just to clarify, define this public IP, you need to go to your Paperspace console by clicking on that little circular button. So go to console and then click on the setup cogwheel for your machine. You'll see there's a private IP. If the public IP says NA, that means you haven't assigned one. So just underneath there's a button that says assign public IP. That costs $3 a month, okay, if you do that. If you don't want to do that, you can instead do this on AWS, which I think Jeanette will show us in a moment. On AWS, we can get a T2 micro instance for free. So, so once you've set assign public IP, it should, assign, it should pop up. There we go, it pops up in a second.
Yeah, so once you have done that, log in into your computer at Paperspace and make sure that you have this, like, you know, inside the directory .ssh, you have these authorized keys, okay? And finally, I found that when I tried to edit the SSH config file, it already had the right permit root login. But basically, in principle, you will go, you know, sudo nano, basically this line in here that I'm pointing at, and make sure that the line that has permit root login basically says without password. When I tried to do it on Paperspace, it was the case that it was like that, but you may want to double check that that's the case, okay?
Nano is a text editor, so when you type sudo nano and that, it's opening up a text editor called Nano. If you've never used it before, it shows you at the bottom of the screen what Control X, Control W, whatever, what everything does. If you're more familiar with Vim or Emacs, you can obviously replace it with Vim or Emacs. But for people that haven't used Unix style text editors before, Nano is perhaps the easiest one to use.
Okay. And then finally, you have to type in your computer, you have to type reload SSH. That's on Paperspace computer. Okay. And then the next time you try to SSH there, you shouldn't need a password. So
don't do this until you've got SSH login working, because if you do this and you're not sure SSH login is working, you won't be able to get back into your machine at all, and you'll have to delete it and start again.
okay, so I did it this morning and this kind of worked, no problem. Check that the inside these authorized keys you have the right key. Basically, you do cat that key, and it should be the same as the one you have in your computer, right? That's the only thing you have to change. You have to check, no? Permissions. So what do you think we need?
Well, if you use what they suggested, which is to use the SSH copy ID function, which is different to what you suggested, it'll set up the permissions for you. And SSH is very strict. If any other user can read your, the wrong users can read your authorized keys file or SSH directory, it won't work. So that's the most common reason. So using that SSH copy command is possibly a better approach than the command you suggested, because it'll make sure everything's set up correctly.
Okay. Okay. Okay, any other questions? Are we good here? Okay. Then I am gonna go and try to explain
So I think the username, so it's not user at, it would be paperspace at, because the username in paperspace
is paperspace, yeah.
Paperspace.
Yeah.
So it would be SSH copy ID paperspace at. And then,
yeah, so that's what I have, right? Paperspace at. Mm-hmm. Yeah. So basically, this is I changed it for you guys here. Okay. Okay. So everybody good?
So on the Mac here, we don't have SSH copy ID, FYI.
So I basically I don't have that either, actually.
Let's just see. Here we are.
I do.
I'm just looking it up because this is going to be much easier. Here we are. Brew install SSH-copy-ID.
Okay.
Assuming that you've installed Homebrew.
Yeah.
I'll add that to the.
Yeah, you're right. That's I was kind of rushing this morning, and I I didn't realize I could just kind of So this is another possibility. Instead of doing that, what I did right here, the cat and all of that, you use just SSH copy ID, but you may have to install it.
That's possible.
Okay.
That's it. And then we install it here. And so this is the password.
Okay. Ask Jeremy to pass you the.
So do we set up the authorized key folder on?
That is it's not a folder. That the .sh is a folder that you create.
Okay.
The other one is a file.
So how do we get? So that's your public key file then.
That's the public key file. Yeah. I mean, a better way to do this is actually just kind of using this command here. Instead of user, you use paperspace. Okay. Most people are done. Should we go to AWS, or are people having problems?
I think we'll try it.
We're good. Should we go to AWS? Yeah, sure. Okay. So. No. So okay, so I have another document that I already shared with you on how to do SSH to AWS. And let me get to that document for a second here. So you can open this document. And basically, I am going to create some similar key pairs on AWS first. And I am going to, so what I'm going to do right now is I'm going to create some kind of similar key pairs, but this case, I don't know, Jeremy, I just kind of use the key pairs from AWS kind of separately than the other ones. You just kind of use the same. You just, that.
No, I think this is probably
that's kind of what, yeah. So I just keep them in this case separately, yeah.
Yeah. So you can either upload your key pair to AWS, or you can get AWS to create a new key pair for you. So Net's going to show us how to create a new key pair. Either way works fine.
Yeah. So Yeah, so let me just kind of show you that. So you go to, I think we have EC2 already here. So if you go to EC2, you see already Jeremy has 3 key pairs, you know, but you can go and open there, and you can always create a new key pair. Okay, so I'm gonna create another one, and
so
then you're
import key pair would be how you would import the one you just created.
Okay, yeah. So you can import your public key, the one you just created right now, or we can make kind of new key pairs. I guess I always did it this way, so that's kind of how I'm gonna teach you how to do it. So you create a key pair, you give it a name. I mostly give it a name, something called AWS something, you know. AWS key is a good one, but since Jeremy already has one, I'm gonna call it test, because then he's gonna delete it later. Test AWS key or something like that. Yeah. So one important thing is that once you create this, you are going to get a similar, but this time like your private key, okay, that you have to keep because AWS is not going to have it, right? So you have to kind of copy it to the .ssh directory, okay? And you should have it, otherwise you're not going to be able to use this key anymore, okay? So basically you take that PEM file and you put it under your .ssh directory, copy it there, CP, copy there. When it downloads, most likely downloads to your download, place in Mac is the download part. Okay, so we do that. So basically have it here in this document. So you create your key pair, you move your PEM file to a safe place, such as .ssh, and then you have to use this change mode 400, and basically change mode is just changing the permissions on this particular file, okay? And if you don't do that, AWS is not going to like it, and it's not going to let you use it.
Your local machine won't like it. Yeah.
Won't like it, yeah,
those 3 numbers refer to the permissions for you, for the group you're in, and for everyone. And they're basically bitmaps. So 400 means no permissions for the group you're in, no permissions for everyone, and then the 4 says that you're allowed to read it.
Mm-hmm. Okay. So now after we are done with that, we are set with the keys. And the next thing I'm gonna do, I'm gonna launch an instance of AWS. Okay.
To find this Google document, by the way, you can find it in 2 places. I've put it at the very top, the first thread of the InFast discussion. I've also created a new thread called Wiki Thread Intro Workshop. Everybody can edit that thread, and I've put these links in there. And any other links or tips, feel free to edit that Wiki thread yourself and add them there.
Yeah, and I wonder, my idea of today is that we can actually launch a real AWS instance with GPU, but I don't know if that's kind of what I thought we were doing, so that is set up, You can, let me tell you what I realized yesterday so that you know how cheap, AWS could be. So I realized that I stopped an instance since part 2 and I never terminated the instance. So I stopped the instance, when was part 2 finished? In May, no, more, something like that. And I got charged $18. So stopping an instance for a while is not a big deal. The problem is if it is running, okay? So I just realized that I never terminated the instance, that it was been running for a few months. So they don't charge you very much for that, okay? So I think if we create an instance right now, I don't know if that's a good idea.
You need to stop it.
You need to stop it, but you don't terminate it. You need to stop it, and you can have it stop for us. You can stop it every time you use it, and you can have it like this for the whole 7 weeks of the class.
When it stops, you only pay for the storage.
For the storage, yeah. And that's what I was saying, that I was charged $18 for a few months on storage. So we can create one right now for you, and then if you want, you can just keep it around, that one. I don't know if that's a good
If you
idea.
create a T2 micro instance, that will be free for the
That would
first
be,
year,
yeah,
but it
okay.
doesn't have a GPU.
But it doesn't have a GPU. So it's up to you right now if you want to create like a GPU instance and keep that one for a while, or if you want to create like a little instance so that we can test that we know how to like set up SSH there. Okay. Okay. So we know how to log in or whatever. Okay. So how we do that? So we go to the EC2 console. Remember we were here, but we can just go to the EC2 dashboard. Launch an instance. Okay. So the first thing you wanna pick is an IMI. So I think Jeremy is thinking about giving you an IMI. An IMI is basically a template with a lot of things that are already installed, right? And it's kind of handy if you have the right IMI because then you don't have to install anything, right? I found out that they have some deep learning IMIs, but they are not good enough for us. But for example, I'm just gonna select this one. This is an Ubuntu. I usually select Ubuntu because the other one's kind of, wait, sorry, it's not this one. Let me go down, Deep Learning AMI Ubuntu. So it has almost everything we want, except that the Python version is Python 3.5. So it's not gonna be good enough. But anyway, so I had to install a lot of things. I basically got this one, and I had to install a bunch of things. So
yeah, so you guys don't need to worry about that. When the course starts, we'll show you the special fast AI AMI that you'll be able to install.
So then today
work straight away.
we can just kind of select this one for fun. So we select this one.
And honestly, the Amazon Deep Learning AMI is like always ridiculously behind and has lots of terrible choices. So like, yeah,
you have to install everything. So so there are all these different instances
yeah, so there's
here.
the free one that's
the free one.
by default.
I just wanted to also go down a little bit and show you the GPU ones so that you know where they are. So Jeremy, if you had to pick any of these for the class, would you pick like
P2 X large?
This one?
Yeah, it costs 90 cents per 90 cents per hour.
Yeah, and how this compares to the one on Paperspace? This one.
Like 3 or 4 times slower, I would say. Although if you scroll up a little bit, there's also a G3.
Okay.
Scroll up a little bit.
Up. Okay.
There we are. G3 for X large is about the same price as the P2. It's a faster GPU, but it's got less memory.
I see. Okay. So another thing that I found, let me just kind of go through the process and ask Jeremy what he thinks. I find this UI like a lot more complicated than just kind of the Paperspace UI is much better. So let's just kind of you can just kind of review on launch, or you can try to configure I don't know if you want to show how much memory would you need for this.
Let's go through with a T2 micro and do every step. So let's show. Let's go next to configure instance and we'll see all the choices we can make.
Okay. So here what we have.
So pretty much all the defaults should be fine. I think it's worth pointing out. Just scroll up a bit where it says shutdown behavior. Up down a little bit. Yeah, at the bottom of the screen there it says shutdown behavior. So if you click on that arrow, the shutdown behavior, you can see that the choices are terminate or stop. So you want to say stop, right? So the difference between terminate and stop means it's not the computer's shut down, but your data is kept. When you say terminate, that kills your box. Like the data is deleted, right? So you don't want to be so if you accidentally have the wrong shutdown behavior, as soon as you shut it down, your whole computer is thrown away. So just be careful not to ever terminate your computer, because that loses everything. There's actually something called termination protection immediately underneath. I would suggest checking that box that says protect against accidental termination. That will tell you if you ever do anything that would cause it to terminate, it'll say you're about to lose everything, are you really, really sure, and make you jump through hoops, which is probably a good idea.
Okay, so all of this is good, and our next one is storage. So let's go. This is good, no? This is good.
Just make sure you click on the bottom left-hand side.
Yeah. So here, how much size do you think we would want?
Yeah, so this is where your net spent whatever it was, $13 for a few months. I think 50 is, for a T2 micro that you're just playing with, 50 will be plenty, and it won't cost you much more than a couple of bucks a month. So.
So if you, what happened to me is that I left the default. And I got out of space. Somehow.
Oh, actually, so you can get 30 gig for free. So here you might want to say 30, and that way this is not going to cost you anything for the next 12 months. It's not going to let you install heaps of stuff, but it's fine for playing around with.
So what would be a good amount for an instance for the whole course? Or
I'd say wait till we get there in the class, because everyone's going to get one created. So I'd say use 30 for this one.
Okay, I'll use 30.
Because free is good.
Okay. Okay, I'm not gonna add tags.
Let's keep clicking next and see what's there.
Okay.
There might be more choices.
Yeah, I keep clicking the wrong one. Okay.
Okay, so security group is important. So we'll take a look at the next configure security. So you can see by default, the only thing you can do is SSH to the computer, which is probably what we want. So I think before we finish today, we should show how to use an SSH.
That's what I want to do. Yeah. That's what I want.
The only thing you can connect to is SSH, and that keeps it nice and secure. So we'll leave that at the default.
Should we just review on launch?
We should have had an option somewhere to create an elastic IP. Did we miss that somewhere? Might be in step 3, configure instance. Otherwise, we won't get a SSH to it.
I got an IP by default without doing
anything.
Can
you scroll down a little bit here?
Okay. Instance details.
Assign public IP. Oh, here you are. So your default is set to enable. So you can see there it says assign public IP, enable. Just make sure it says enable there. Otherwise, you won't get a SSH to it.
Okay, so I'm gonna launch this, and here it's gonna ask me which keepers I'm gonna use, and since I just did this test once, I am going to select those. So note that you have to have the PEM file if you wanna access the. So, and then we just kind of do launch instance. We have to.
Okay, so that means that the particular AMI we used requires 50 gig minimum. So
yeah, that's actually what happened to me.
Oh, that's because you used the deep learning AMI.
Yeah.
So you probably don't want to use that with
let's just kind of
micro.
Edit an AMI.
Just use Ubuntu, which is just down a little bit. There it is. Yeah.
Okay, so I'm just going to review on launch here. Everything else should be fine. So
So those billing alerts are a good idea, the thing that's mentioned in blue. So we don't have to do it now, but you might want to take a look at that. Just scroll up a little bit.
Yeah.
So you can click on create billing alerts and say like, okay, if I ever get charged $5, send me an email, for instance.
Mm-hmm. And now you just do view instances. So you see this one is already, it's initializing, it's already running. And if you click on it and look at the, we have a public IP here. We also have this public DNS, and we can use either of them to SSH. So you have to paste and copy that. Okay, let me go back to my document here for a sec. So you basically paste and copy this public IP, and then you can just do something like SSH -I. You have to point to the keys. Remember that we gave AWS the name of the key that we were going to use. Well, it has to match the one you're given here, right? You can have multiple key pairs going on, right? But you have to kind of do the match. And then if you're using Ubuntu, the username is usually Ubuntu. If you're using another AMI, the username may be different. So keep that in mind, because I always get a bit confused. And then I'm like, why I'm not being able? So it's basically, it doesn't allow you to SSH and doesn't give you a very good explanation. So you may want to have that in mind. So you should be now able to SSH to your instance. Can you let me know if you are able to or not? Yeah, you want to send the, yeah.
So yeah, my question is, if we're gonna use Paperspace, do you suggest that we should also use Amazon, AWS, or it's just a preference?
You know, this is what, so the thing about it is that we may get some money from AWS, right? It's like we're expecting to get some money from them. Yeah, it may be like right now, let me tell you, like I have $500 on AWS, right? So Paperspace is really nice, even if they gave me also some money, but maybe you want to go for free, right? So Paperspace may be really nice, and maybe you get into a project in which you actually need the actual power of Paperspace and you leave, then you go there for that. But it may be that we get a lot of money from AWS and you just go for free the whole course, and the minute that you are out of credit in AWS, then you go back to Paperspace. Everything is gonna kind of work the same, right? Like you just have to remember what is your public IP, right?
I'm gonna say the thing I've been trying to avoid saying, but
yeah,
since everybody's like making me say it. So this is not certain and not to be shared anywhere, but we may be getting access to some as yet unreleased instances that are amazingly awesome and nobody else in the world has access to, maybe. Okay, so if you don't put your AWS ID on the sheet, you're not going to have any chance of getting the treats if they happen. Okay, so no promises, but we may be able to get access to things that nobody else in the world has.
Yeah. So it's not that complicated, right? Like, I mean, I don't know if my explanation was kind of make it seem cumbersome, but it's not that complicated, right? And this is a process that is very kind of regular. You will have to do this with many other places.
In the main class, most of what we're teaching, assuming we get the treats, will be shown in AWS. Most of the discussions on the forum will be about using AWS. So, you know, I mean, Paperspace is there too, and it's pretty cool. But,
yeah, actually, by the way, I finally wanted to tell you about tunneling, because I wasn't able to get Jupyter to show in the right way. And I didn't know anything about tunneling, and Jeremy mentioned it. And then when I was trying to find the solution to the Jupyter problem, then I actually came across this very handy thing. So if instead of doing SSH in the right way, in the way you do it here, you do it in this way here, then what happens is that you can, when you launch Jupyter, you can have Jupyter as your local host 888. And it just kind of works very beautifully.
Right, so that -L parameter creates something called an SSH tunnel. It listens to your personal computer's port that's in the first number, which in this case is 8888, the thing before that colon, right? And then after that colon, it listens on the remote computer port 8888. And then after the colon is what it listens to on your computer. So this creates a tunnel from 127.001:8888 to port 8888 on the remote machine. And that means if you go to your browser and type 127.001:8888, 127.001 is the address of is always the address of your computer. And it's going to forward everything there to the remote computer's port 8888. And therefore, by typing into your browser 127.001:8888 or localhost 8888, which is the same thing, you will get a Jupyter instance on your personal computer connected to the remote machine's Jupyter without having to open up any ports or create any security issues. So it's like super, super, super handy. And we will cover this in the course as well. So like you're just getting a preview of this so that you can try it out.
Okay, so we have like 5 minutes, so I'm gonna.
Are you going to spend 5 minutes on test validation?
Yeah, let's just go there. So we wanted to cover some more things, but I guess that we don't have enough time, so we're going to just talk briefly about. Not about machine learning exactly, but so I think I'm just going to go for actually let me just kind of start by here, because otherwise I'm not going to be able to tell you why what I'm saying makes sense. But so an example of a machine learning problem is the problem of predicting if a user is going to click on a particular ad. Okay, so how do we model that problem? Well, the way we model usually this problem is that we have the independent variables, that we call it, which are features of the problem, like the number of words in the title, the category of the query, number of action words in the ad, and many other instances, right? And then we have the output variable, which is the response variable, which is basically either the dependent variable, either the user is going to click or it's not going to click. Okay, so that's my little problem for today. So what is machine learning? So machine learning assumes that there is a relationship between X and Y, right? There is a function that tries to model X and Y, right? In which X is approximately, Y is approximately equal to f of X, okay? F is fixed, but we don't know what is X, F. And what machine learning does is to try to produce an approximation for F, basically, right? So it's some approaches to estimating the function F. I'm not gonna talk about this. Y could be quantitative or qualitative, and if it is quantitative, we call it regression. If it is categorical, we call it classification. In deep learning, you're gonna see that we don't care too much. They are kind of the same for us. We can treat classification and regression in very similar ways. Training data are the observations that are used to estimate the function f, right? And then we have some other data set called development data set and test set, okay? The development data set and the test set are used to understand how good is F, okay? Because you use the training set to train F, right? So you want to use an independent set to understand how good is F, okay? So why is that, actually? The main reason is that what we want to do with machine learning is to predict unseen data that we haven't seen yet, right? So if we feed our training data very, very well, but the unseen data is very bad, then machine learning we haven't done anything, right? So that's why we need a separation between the training, which is the data used to actually get this F approximation, and the test and validation set, which are data sets that are used to understand how good this function is, right? So then why do we need two sets, like validation and test? Well, it turns out that, especially in deep learning, there are something called hyperparameters, and we are going to talk about those. And we need to tune those to get a good model. Once you are set on a model, there are these many other things that you need to decide what they are, right? And to be able to get those, we use the development set or validation set also, right? And what happens is that if you use the validation set too much to set those, then you also are kind of overfitting a little bit that set, right? So then if you actually wanted to say how good your F is, now you will need another set that will tell you exactly what is the error that you will be able to see in a new data set, right? Okay. In many cases, sometimes we don't care about having a test set very much, but then we shouldn't assume that the value of the validation set is actually that real, right? Is that I just want to say that.
In the course, we'll be calling it a validation set.
Yeah, a validation set. Yeah. Okay. So any questions here? Okay. Okay. I think I basically. So this idea of generalization error is the error on unseen data, and that's what we would like to minimize, really, right? So the training error, which is the error on the training data, is in general smaller than the error on data that the algorithm hasn't seen, okay? In general, it's smaller. Okay, and I think that's it. I mean, we have some more things to cover, but they're all there. And
this is a really big topic. We'll come back to it a bit during the course, but we're assuming some familiarity with it. So if this idea of test validation and training sets is new to you, then again, there's lots of information about this online. It's a really old classic concept, and hopefully if you find good resources, you can share it. And now that the wiki thread is up, the best place to share it is to pop the link into the wiki thread.
Any final questions? Yeah.
Well, yeah, I might briefly mention Tmux. It's certainly handy.
Okay, all good? Okay. Thank you.
What all shall we have ready to go before the next class? Is it before the next class? Shall we install
do something in particular before the next class?
Install some Python library, or make sure we have Amazon Instant connected and SSH, right? So
I'll let.
I'd say whatever bits from today you're least familiar with, just practice them. You know, there's no particular thing you need running, but all of this stuff from today is kind of stuff that we will be assuming that you have some comfort with. Yeah.